Well, good morning, ladies and gentlemen. I'll just give you a few minutes, a few seconds to take your seats. I just want to say a very, very warm welcome to this year's summit. My name's Daisy McAndrew, and I'm so flattered. It's always very flattering to be invited to take part in an event like today, but it's even more flattering to be invited back. It means you can't have completely messed up last time, but more importantly, for me, I now feel like I really am part of the family, which is lovely. And also I feel like I truly understand. I mean, this is, believe it or not, the fourth summit, and I think it's my fourth as well. And goodness me, how many leaders of the Conservative Party have we been through in that period of time? But we are still here and actually talking about something that matters much more than who is leading the Conservative Party. This is an industry that provides real jobs to real people and is undergoing a huge, monumental amount of change, which is what gives us so much to talk about today, how to cope with that mind-boggling, discombobulating change, and getting advice from experts on how we can navigate these choppy waters. So I just want to say a very, very warm welcome to, obviously to those in the room, but also to those who are joining us virtually, of whom there are a lot today, thousands. So a very warm welcome to all of you. I just need to go through a few housekeeping points. I'll keep it brief. We have no fire alarms planned for today. So if there is a fire alarm, it's the real deal. Follow the fire wardens who'll be wearing high vis and go out to the car park. Wi-Fi, very, very simple. I've done it already. You just log on to MTC Guest. There is no password. Bathrooms are on the ground floor opposite the staircase. Obviously, this is a no smoking, no vaping building. There is a smoking shelter outside. If you need first aid, do speak to a member of the events team. And finally, there is a multi-faith room should you need it, and it's on the first floor. That's the boring bit over and done with. Now on to the exciting bit. But of course, events like today are expensive. Let's be honest about that. And so we need help. So we're incredibly grateful to the help from the headline sponsors, Lloyds Banking Group, Manufacturing Technology Centre, and the manufacturer. So a very, very big thank you to them. Also, thank you to all of our exhibitors and other sponsors that can be found in the exhibition centre. Do go and have a good nose around and see what they've got to offer. Here's a quick look at today's agenda. If you want to follow or access the agenda, you can go to the website, which is on the screen. It's nmsummit.co.uk/guide. Or if you're here in person, you can just have a look at the QR code on the back of your pass and download that, and that will take you straight to the agenda. And also, very, very importantly, it'll take you to where you need to pose questions, because this event, as ever, is a two-way conversation. It is not a one-way lecture at you, but we want to hear from the audience, both this lovely audience, but also the audience joining us virtually. So use the website, scan the QR code and send us questions that way. And I promise to get through as many questions as I possibly can. And I'll be, if you see me looking at the iPad, that's what I'm doing. I'm not doing my online shopping, I promise. I am looking at your questions, and I want to put as many of those questions to our audience. That is pretty much it on the housekeeping. It just leaves me now to introduce the Chief Executive Officer of MTC. This is, unlike mine, this is his first summit, and I'm sure he's got an awful lot to tell us about where he thinks things are heading, what his opinions are on this industry, and also tell us a little bit about himself, introduce him. Please give a very warm welcome, ladies and gentlemen, to Graham Hoare.
Good morning, everyone, and thank you for joining us here today. And it's a pleasure to welcome you to the MTC. This is the fourth summit, as you've heard, and it's a program that's really important to us because it brings together all of the stakeholders that can really influence the direction of the manufacturing sector in the UK. It's certainly a highlight of the MTC's calendar, and hopefully it's a highlight of yours too. Our objective really is to remind ourselves of what's been going on in manufacturing over about the last 25 years, but to use that as setting context for what's happening now and what we'll see coming in the next 25 years. And that glimpse into the future is really important. It's opinion formers like yourselves that will ultimately inform how the direction of our industry unfolds. Alongside this, we're going to look at the skills required to fully realise the visions and the technologies that we'll be sharing today. So how do we bring context to the skills gap that we all talk about? How do we start to really make a difference and transform it whilst transforming the landscape of the technology that we'll all be using? We really need to make sure that the UK remains at the forefront of manufacturing technology, a true manufacturing nation. And through these technologies and through the skills we'll discuss, that's our route forward. So let's put in context the pace of technology change. And some of these analogies you will all be familiar with, but they should be phenomenal background for the challenge that we face in our sector. So back in the 2000s, about 1 billion people had a mobile telephone in their hands, and today about 7 billion people have that same device or a new version of it in their hands. So a massive transformation. In that same time frame, back in the early 2000s, the DVD was starting to replace the videotape, the VCR system, and effectively now we're on a streaming platform that has completely transformed again. So 2 generations of technology have flown through in that 20 years, and that change, that streaming change, has transformed television. It's transformed the way we engage and the way we are entertained. That's the kind of transformation that manufacturing is now embarking upon. So changes in technology within our sector are equally dramatic. The number of industrial use robots has grown from around 10 years ago at 1.3 million globally to about 4 million globally today. And that's set to accelerate to 6.5 million by 2026. About half of those, almost half of those, 40%, will be actually in China. They'll be outside in an area that is obviously fiercely competitive. And it's set to grow. The expectation is by 2030 that number will be about 10 million. So, sorry, 20 million. So the rate of change is happening. It's happening around the world, and we must be part of it. 25 years ago, digital technologies such as the Internet of Things and Bluetooth manufacturing didn't exist, but are now the backbone of everything we do. These technologies allow for increased efficiency through monitoring and exchange of production data in real time, even linking to real-time models and twins. So these transformations are upon us, and how we exploit them will determine how successful we are in the future. Disappointingly, the UK is still only installing a few thousand robots per year at the moment, and we are slipping down in the robot adoption tables compared to our competitive nations, and therefore our productivity and our economy is vulnerable. So our challenge is to very much change that statement. So this year's summit promises to bring clear focus to these issues and the pace of change that we're seeing through these technological advances, and understand how the workforce of the present will be evolving and will need to evolve to support the future. Events like this are really important as they facilitate discussion between industry, government and academia, and put a catalogue, create a storyline of how we will work together, how we will roadmap to ultimately change the outcomes for the UK and deliver the manufacturing ambition that we now clearly have as a nation. So manufacturing has enjoyed a renaissance in the UK in the last 12 to 18 months particularly. We've seen announcements from the government in the autumn statement, including the Advanced Manufacturing Plan, signalling a really positive commitment and energy behind manufacturing that we haven't enjoyed for 20 years. And that step change in approach and attitude is it's contagious, and we need to really capitalise on it. The £4.5 billion of funding towards strategic manufacturing has the potential to fully reinvigorate our industry and create a new platform for us to drive our businesses forward with. Development of technology is also moving at pace in this same time frame. So technologies like additive manufacturing are now being deployed on a much more broad basis across industry, and also in areas like spare part manufacture, medicines, limb replacements, and much, much more. So the democratization of these new technologies, we're on the brink of those transformations. However, we also look to the future and to other opportunities that will supercharge the environment we're living in. The use of artificial intelligence and automation will be key to facilitate our transformation and the resurgence to ensure that we are on the top of the plane as the opportunities unfold. There are some phenomenal examples around the world of how environments have united to create transformation. I'll cite the Pittsburgh Robotic Cluster as a really good example. Many of you in the room will be familiar with it. Back in 2012, a dedicated and strategic decision was made in Pittsburgh, North America, to create a technology hub for that region. That was an extremely strategic move across that nation. Since then, over $3.3 billion of investment has been made into that region, into that cluster. Over 600 patents have been filed. 100 companies are engaged in that project, and over 45,000 technology workers are now employed in that region. That was transformational for Pittsburgh, but it's also been transformational for North America. It's been the accelerator for the nation. So North America now is adopting these technologies faster because it can see the advantage. So national impact, profound impact, possible if we put focus, and that was real focus. The UK has both the knowledge base and the technical capability to drive similar programs through the support of our world-class ecosystem. And having had the opportunity to work in many of the locations around the world, I truly believe that the ecosystem we have here is world-class. Whether it be catapults, like one that we're in today, universities, research and development organisations, and the capability to collaborate. It's unsurpassed internationally. We have to work that muscle together. Together with the rapid innovation and resurgence in manufacturing, there's a massive need to manage our skills agenda. The future requires a workforce that's capable and effective with these new technologies and able to operate successfully in that brave new world. So there's a need not only to train the next generation of people that will ultimately succeed us in taking this journey forward, but also to retrain the employees that we have in many of our companies up and down the nation. And that requires some really consequent action together. And we are responsible for this. So a skills strategy needs to be outlined by industry leaders in collaboration with academia, and with the support of government, we need to drive it hard so that we don't miss the curve. Centres such as the MTC Training Centre that you're in today, part of the MTC organisation, are very much part of that journey. And we can provide some of those transformational skills alongside many colleagues up and down the nation. It's really important that we define the projects, define the programs, and ultimately unite in delivering that transformation. Throughout the day, there'll be various industry leaders that share their opinions on how we will journey forward and what we need to do together to deliver this challenge. These keynote speakers will give us great insight. There will be an opportunity to engage with them through Q&A sessions, but also to really understand their points of view and how we can really rise to the challenge. Please take the time to engage with them, to engage with the broader organization, and let's use this time together to really make a difference. I'd really like to thank the event sponsors for this event too. They've got tremendous foresight and they've provided great insights into building this program for us today. And thank you on my behalf also for the work you're doing to help our industry transform. Please take the opportunity to look at some of the live demonstrations that are available today and sign up if you can for the MTC tours that are existing on the other side of the lake to see some of these technologies if you haven't seen them in action today. There's a great opportunity for a dinner event this afternoon, this evening. Please think of your questions, not only during the day, but also for some great dialogue we'll have over dinner. There's an opportunity with academia, government, and industry really to collaborate on the challenges that we'll explain today. So thank you again for attending, both in the room here today and online. We've got a lot of a journey ahead of us, but thank you for being part of that. I look forward to handing back to Daisy and hearing what you all have to say. Thank you.
Well, Graham, many, many thanks, and a lot of food for thought already there. And so much of what Graham was just setting out really has set the scene for a lot of our discussions, both keynotes and panel discussions. And of course, that all-important issue of skills, which we hear so much about. But what are the answers? We know there's a problem. But what's the answer? What's the solution to that problem? So I think that really is going to be one of the very, very big questions that we will aim to give some answers to today, but certainly a lot to get our teeth stuck into. So we're now going to move on to our first keynote speech of the day, in which we're going to be looking at the exponential age. And we're delighted to have with us Chief Technology Officer from Dell Technologies. Please give a very warm welcome to Arash Ghazanfari.
Good morning. And I have to say, it's an absolute privilege to be here to share my perspective and Dell's point of view around the impact of emerging technologies on the manufacturing industry, which is such an important sector and a massive contributor and driver for the growth of the UK economy. So Dell Technologies has been in a #1 position as a technology vendor across several technology product and services categories, but we are also one of the largest manufacturers in the world. So we do understand some of the challenges that our customers within the manufacturing industry face. And if you consider the technological megatrends that are affecting almost every industry, technologies such as artificial intelligence, public and private cloud computing, edge computing, the impact of 5G on the telco industry, robotics, augmented and virtual reality, and of course, in the geopolitical environment that we find ourselves, considerations around enterprise security, we are absolutely active in all of these areas, and we do have relevance. And from within Dell Technology organizationally, we do have our manufacturing practice as well as our OEM solutions and a broad range of partners within our ecosystem to be able to address not only the needs of modernizing your enterprise resource planning and product lifecycle management systems, but all the way down to industrial control systems and your connected assets in the factory floor. So we are very proud to have built this capability, and we would be very open to having conversations with manufacturing customers outside of your typical IT department environment. If we think about the impact of technology on accelerating innovation in any business, we have to start with a fundamental question, which is, what business problems are we trying to address, and what use cases are we trying to bring to life? And if we think about it, it can break down into 3 basic components. You have to understand what data sources that you need to get access to. Can you sense and capture that data in a timely manner? Can you apply some kind of workload or analytics to that data in order to generate actionable insights that would help you create outcomes and value for your organization? And I call this construct the innovation loop. And the faster that you go around this loop, and it's going to be a perpetual journey, the more quickly you can build value and competitive differentiation for your industry. And how quickly you go around this loop very much depends on how you organize yourself and how you construct your technology acquisition strategy, and adopting a unified approach is going to be essential. Now, when we think about the edge, it can mean different things to different people, but from a technology's perspective, the edge is where you act upon the data close to the point that it has been created or captured in order to create value, immediate value for your organization. And in the context of the manufacturing industry, that's often going to be your smart factory floor, because that's where work gets done, that's where value is created, often that's where valuable data is generated, and that's where you need to make time-critical and very important business decisions. Manufacturing has always been at the forefront of innovation and change. So we all know this. Power generation created opportunities for the first industrial revolution. When power generation started to become more centralized, the focus shifted towards mass production. In the 70s, we started adopting electronic automation and robotics to improve throughput. And in the 2010s, we started seeing the emergence of smart technologies on the factory floor, ushering the era of the fourth industrial revolution. But I would suggest that with the rise of artificial intelligence seeping into every aspect of our business and organization, we are now ushering an era of human-machine collaboration, and some exciting opportunities are ahead. And I'm sure that you would agree with me that we can all feel this. The pace of change, the pace of innovation is exponentially accelerating, and it's not going to stop. So we really have to embrace it and take advantage of it. If you think about what's happening in the manufacturing industry, we are already starting to see automatically reconfigured and optimizing production lines. Particularly, we are seeing this in the automotive industry. We've already been experiencing systems that can anticipate failure, and we are rapidly moving towards self-healing systems in the manufacturing sector. The product lifecycle improvement and the rate of innovation is definitely accelerating, and supply chain complexity remains one of the biggest challenges within the manufacturing sector. And at Dell Technologies, we've actually adopted a data-driven approach to maintaining the resiliency of our supply chain, which was highly appreciated by our customers, particularly during the stressed market conditions of the pandemic. Imagine if you're a large bank and you want to keep 70, 80,000 employees safe due to lockdown. You have to change your operating model overnight, and you absolutely need a vendor that can deliver those capabilities to you in a very short time frame. So having sophisticated demand signals and a data-driven approach to managing our supply chain has given us that competitive advantage of maintaining resiliency around that, which is going to be hugely important in the geopolitical uncertain environment in which we find ourselves for the manufacturing sector and, of course, other industries. There are some common themes that are driving the disruption of the manufacturing industry. The OT and IT convergence is continuing to accelerate, largely powered by better private mobility and 5G technologies. Sustainability and efficiency is top of mind. It's a board-level priority for many organizations. And with digital twin technologies, we can have superhuman powers. I can teleport to a system and understand what is actually happening with its characteristics under its operating conditions without actually physically being there. I can go back in time to understand what was my system going through and go forward into the future to carry out what-if analysis and find the most optimum scenario for most efficient operations without actually having to physically make those changes. And all of these systems are powered by artificial intelligence. And artificial intelligence has been with us for quite some time. What I'd like to call as classic AI, it has largely been about detecting patterns, generating insights, making decisions, but based on existing data. And the use cases around the manufacturing industry powered by classic AI capabilities are plenty. There are many use cases that we have brought to life for our customers within Dell Technologies' own manufacturing lines. We are actively using computer vision, for example, to improve quality assurance and increase the throughput of our manufacturing capabilities. And if you wish to talk about any of these use cases with me, please feel free to find me during the break, and we can absolutely talk about the steps that we need to go through to discuss this further. But what's really changed in the artificial intelligence landscape, and words like ChatGPT are now common terms in everyday vocabulary. You can't really escape it. The idea behind generative AI is that you have this conversational interaction with an artificial intelligence system, and it can create new synthetic data. And that's really taking things to a whole new level. And the way that we manage our data and have governance around our data and control around it really has to be top of mind for everyone who's thinking of adopting such technologies. Now, I'm approaching this conversation from a position of humility. I did study mechanical engineering, but for various reasons, I decided to go into high tech, and I didn't really pursue a career in manufacturing. And I've never had the opportunity to work with CNC machines or know much about G-code. But I thought, well, what if I go to ChatGPT and ask it to produce G-code for machining a cylinder of a certain dimension? And it did so, and it helpfully suggested that perhaps I should consider issues such as feed rate or roughing and finishing passes. I said, okay, well, why don't you do that? Why don't you create a slightly more comprehensive code that takes into account tool changes, suggest the appropriate feed rate, maybe take into account roughing and finishing passes? And it did. To me, it looks pretty okay, but imagine if you pair this technology with someone who actually knows what they're doing, what impact it would have on your productivity. I asked it to recreate the code again and create something slightly different. I have no way of discerning if this is correct or not, but you can see the potential. Now, if I take this slightly in a different direction, this conversation in a different direction, there are some pitfalls with using such technologies. Your data is going to be out in the open. The AI models that you are interacting with aren't necessarily trained on your data, specific to your needs. The environment may not necessarily be secure. And the reality is that these tools can be open to abuse, which is why I understand that organizations like OpenAI, big investors like Microsoft, in their terms and conditions, they do have things like abuse monitoring process, meaning that the prompts that you put out there, the requests that you make, are going to be retained for up to 30 days, and are open to being monitored by other human beings. Now, if you're a large legal firm, a governmental organization, a financial services institution, or indeed a manufacturer, the last thing that you want is for your intellectual property to be exposed to the wider world, or for your critical business data to be used to train AI models that could potentially be abused or maybe exposed to your competition. And that's a very critical aspect that we need to take into account. But with the right guardrails and the right approach, I can easily see a future where, based on vast amounts of historical data that you have at your disposal, you could, for example, ask a generative AI model to produce the wireframe for the next engine block, the next iteration that is more performant, quieter, more efficient, leveraging 15% less material, and by the way, minimize the cost of retooling my current tools and processes. I can easily see that happen, and it could be with us much earlier than we anticipate. So I think it's important that we prepare ourselves for what is actually coming. And this is partly why at Dell Technologies we have worked really hard to build an ecosystem of capabilities. We don't claim that we have all the answers. We have a large ecosystem of partnerships at our disposal. And we want you to be able to have a unified approach to how you adopt these technologies, have the right guardrails in place, have the right strategy in place, making sure that you're absolutely in control of your overall digital supply chain end-to-end, from the point that data is created all the way to where insights are generated and value is delivered to your organization, making sure that it's all done in a sustainable and secure manner. And we have built the platforms to be able to do this. Now, I would suggest that in this room and the audience who's watching us remotely, there's a lot of expertise around the manufacturing industry. And it's a privilege to be amongst you. And I would humbly suggest that it's much easier to turn a manufacturing domain expert into a technologist rather than the other way around. So investing in your people, staying curious around technology, working with organizations like the MTC, in my humble opinion, and also staying curious around what other technology organizations like Dell Technologies and others have to offer would be a fantastic starting point to build the foundations that we need to take advantage of the disruption and the innovation opportunities that is actually coming our way. And I would suggest that the time to do this is now, and we shouldn't wait. Now, from Dell Technologies' point of view, we do have executive briefing capabilities. So the idea is that we work with you to understand your organizational and board level priorities and create a bespoke agenda that is suitable to your requirements and cover what I have discussed in a lot more detail that is relevant to your objectives. We also have customer solution centers. The closest one to us is in Limerick, in Ireland. This is where we have built a lot of these use cases, and we can actually bring them to life. We can do deep dives and explore ideas together. With that in mind, I'm going to give the organizers 4 minutes back, if you don't mind. I'm going to be here for the rest of the day. Please come and find me. Some of my colleagues are here with me as well, and we would be really happy to connect with you and get to know your objectives and priorities in a lot more detail. And I'd like to invite you to enjoy the rest of the event. Thank you very much.
Thank you so much. Really, really interesting. A lot of information, a lot of course, some answers, but a lot of questions as well. So questions that we can explore in the rest of the day. And we've already heard about what the manufacturing sector can do or should do or might be able to help itself. But of course, it cannot work in isolation, particularly with problems like the skills gap. It cannot magic up human beings who have all the skills. But that's where, in a lot of ways, government comes in. So I'm delighted now to introduce some pre-recorded words from the Cabinet Secretary for Wellbeing, Economy, Net Zero and Energy, Mari McCallan.
Good morning. I'm Mari McCallan, the Scottish Cabinet Secretary for the Wellbeing Economy, Net Zero and Energy. I'm sorry that I couldn't be with you at today's event. However, I'd like to thank the Manufacturing Technology Centre for inviting me to record a message for you all at the 4th UK National Manufacturing Summit. I'm delighted to have recently taken on responsibility for the manufacturing sector in government, a sector that is crucial to the creation of a wellbeing economy, one that's fair, green and growing, and which enables better public services to allow our people to live better, healthier, happier lives. Those links to wellbeing are supported by the statistics. Manufacturing is a high-wage, high-productivity sector. In Scotland, it employs 173,000 people with a GVA per head 50% higher than the average. And salaries for the sector in Scotland is a similar story, 35% higher than Scotland's average. This makes it clear how important manufacturing is to us and why it's receiving the government focus I will outline today. Scotland has an abundance of natural resources. With our history, universities, and the strength of our industry, we can create opportunities to open new markets at home and around the world. Our National Strategy for Economic Transformation, and more recently Innovation Strategy, set out the Scottish Government's long-term approach to supporting these opportunities. Opportunities that are underpinned by the manufacturing sector. A key example is renewables, where Scotland holds huge natural resource potential. Potential that we have already seen commitments towards being realised. Projects such as ScotWind, the world's largest floating offshore leasing round, that's expected to deliver up to £25 billion of investment across our supply chains. And just last month, I announced a £350 million investment from Sumitomo towards a new cable factory for offshore wind. A Scottish Government grant of £24.5 million helped to secure this commitment that's now expected to create 330 jobs over the next 10 years. And this is where apprenticeships and training programmes will also play a crucial role. To take full advantage of the benefits from ambitious projects like ScotWind, our workforce must be equipped with the necessary skills. Against this backdrop of skills shortages, we need a workforce that's ready to respond to the future demands of the sector. And that's why Skills Development Scotland have revised the Modern Apprenticeships Framework in Scotland for engineering. This has been done through deep collaboration with employers, trade bodies, and training providers to create modern and flexible qualifications that will support our future workforce. We also have the National Manufacturing Institute, NMIS, who are also working with industry to support our labour market challenges through projects such as their pre-approved talent system pilots. Pilots that, in the longer term, aim to tackle skills shortages and create more career opportunities for our apprentices. The Scottish Manufacturing Advisory Service is also working with manufacturers across Scotland on continuous improvement and upskilling. So it's important to invest in our people, but equally important to invest in our infrastructure to create the right environment for success. Over the past 2 years, we've opened several new state-of-the-art facilities that have the technology and expertise to help industry grow. Last summer, the First Minister formally opened the flagship building for NMIS in Renfrew, representing a £75 million investment from the Scottish Government. And right across the road, the Medicines Manufacturing Innovation Centre was opened in late 2022. For smaller businesses, there are 12 initiatives providing services free of charge to SMEs in areas such as automation, robotics, or skills. This was the result of our Advanced Manufacturing Challenge Fund. So I want to close by emphasising that I know innovation, investment, and skills are absolutely crucial to our economy, and that manufacturing holds a key role in all of those areas. That's why Scotland has taken and will continue to take the steps needed to realise this enormous ambition. Thank you for listening, and I hope everyone has had an enjoyable and productive day.
Well, many thanks to Mhairi McCallan from the Scottish Government there. Delighted now to introduce the Chief Executive of Drone Major, who's going to be giving us an industry presentation on the drone age. Please give a warm welcome to Robert Garbett.
Good morning. Thank you very much for your time. And I'm hoping that the next 15 minutes will be informative. Clearly, I'm not a manufacturer. I am the Chief Executive of Drone Major. We are an organisation that advises on the implementation of drone technology across a number of sectors, which I'll cover later. The qualifications that enable me to stand here, I'm also the Chairman of the Senior Advisory Board for the Drone Delivery Group, which is the Government Advisory Group, and I'm also the UK lead for the development of all safety and quality standards for UAS. So I do know a reasonable amount about the industry. I'm hoping this will be a little bit interesting, if not light. Okay, this is probably the most important slide of the entire deck. And it's something that not many people realize. When we think about a drone, we all think about the little spider-shaped thing in the air that's going to annoy us with this little camera, which looks a little bit like the thing on the right there. But in fact, if you read the official definition, which is in ISO 213H4-4, I know because I wrote it, it's any unmanned system, or uncrewed these days, that hasn't been changed yet, but it will be, which is remotely or autonomously controlled. No mention of air, no mention of anything. So it is everything. It's an overarching term which is now being used to describe all nature of systems, including, I'm going to come back to that one in a minute, including unmanned air systems, ground systems, and all this kind of stuff. I'll come on to it. But drones are not a new thing. This is a little bit of a potted history specifically about unmanned air systems. It goes back to 1907 with the development of the first multi-rotocopter in France. Wasn't very successful, but good insights. Unmanned wing system. That system on the right-hand side is a targeting drone. Essentially, it was flown in the First World War. 1960s, we started to get a little bit of remote control going on. So we're using toys, still drones, but we weren't calling them drones then. And in 2010, the Parrot launched their first serious piece of kit, which was the AR. And we've seen since then a massively rapid development of technology across all domains: air, land, maritime, and everything else in between. So in the air, we're looking at unmanned air systems. We now have aircraft which are pico-sized, so they fit literally into the palm of your hand, tiny little insect-sized things, right up to aircraft that can remain in the air permanently, so flying around, giving us good intelligence on the ground. We have a multitude of different propulsion systems, ranging from this, which is a gyrocopter, from a company called, can't remember, but it's on the aircraft there, so I do apologize. Aero Robotics, that's the one, the gyrocopter. Right up to massive heavy lift, multi-rotor systems that can lift up to 500 kilograms, right down to the smallest fixed wing or rotor wing system. So a myriad of technology that we could start to use, couldn't we? I'll come on to that in a minute. eVTOL. Everyone gets really excited about eVTOL. Stands for Electric Vertical Takeoff and Landing. In my mind, we are looking at the evolution of the helicopter. It will not replace the helicopter, but it will replace some of them for certain tasks. But you will not see these flying around unmanned with passengers in the back anytime soon. You're probably looking at 15 to 25 years before that happens. So they really are a tool for the helicopter operations industry, rather than, as a gimmicky to take rich people in and out of London without a pilot on board, which would be terrible. I wouldn't get on board anyway. The other version of these aircraft, which are essentially just like very large drones, are cargo carrying, which is I've mentioned already. So they are termed as eVTOL, but they are still unmanned air systems. So as soon as you put a pilot in it, it's not a drone. If you take the pilot out of it, it's remote controlled, or it's autonomously controlled, then it is a drone. MASS, Maritime Autonomous Surface Shipping. And that covers a myriad of things, right from beasts like this. This is obviously a digital simulation, but vessels like this do exist, right down to the smallest systems that we're now seeing used in Ukraine, which is just a retrofitted little small boat or a jet ski with some nice surprise for a Russian vessel. So there are a myriad of systems being developed. The technology that's being developed in this area is phenomenal. It's actually really incredibly difficult to get one of these things to navigate autonomously, because it's so close to, let's call it, the surface of the sea. It doesn't have a lot of height, a lot of perspective, so it has to basically navigate its way through a moving surface, which is incredibly difficult, aided now more so than any time in the past by AI. And that is speeding up the development in this sector. ROVs and AUVs. These have, for many years, been stagnating in terms of their development. The reason for that is mainly because the oil industry has squeezed the budgets for those companies that were developing this technology by giving them a 3-year contract and then saying, we'll renew it if you charge half the price, and then doing the same thing next year. So a lot of innovation was quashed, not a lot happening, but in recent times, we are seeing huge developments, mainly coming from the defense sector. So it's one to watch for. And the AUVs, so you've got ROVs, remotely operated vehicles. Those are the ones that are on tethers. And AUV is an autonomous underwater vehicle. Why we have two completely different terms, I don't know, but there you go. It's autonomous underwater vehicle. These are the ones that are now being deployed worldwide to monitor the state of our oceans, the fitness of our oceans, and they can stay out there almost permanently. And they are powered by a variety of things, including wave power and all sorts of things. So another sector to look for. UGVs, unmanned ground vehicles. Obviously, what we have here is a simulated sort of autonomous bus, and we have seen some driverless buses clearly with drivers in. I'll come on to what the future of that is in a little bit. But UGVs is a class of drone which covers everything from the small ground systems that you see in manufacturing or logistics facilities right up to the bus or the large truck that's going to have its own lane, hopefully in the future. But we'll cover that when we get to the future piece. There are three key sectors in my mind. The first is that of defense. Clearly the mother of all drones, essentially. This is where it all comes from. And obviously the area where development is moving very, very quickly for obvious reasons. It is an area that we work in quite extensively, and we are seeing a phenomenal amount of development. One of the key developments is manufacturing. What people don't realize is that many of the manufacturers of unmanned air systems, for example, have developed them to be an answer to everything. So they're a 20, 30, 50, 70, 100,000 pound piece of kit, which has got lots of advanced sensors, and it can fly for an hour and a half, and it's absolutely fantastic. Sadly, the market for this now is down to, I want something I can send and I know it's not going to come back. So drones in defense have moved from being an asset to being a disposable commodity. So from, essentially, the analogy would be from a tank to a bullet. Okay, and that is what they're being used for. And what that has done is led to a revolution in manufacturing, where we now have suppliers that can produce 100,000 drones, 10,000 a day. They take 3 minutes to assemble. They can be shipped to the front line, programmed with open source code, and it can go to a myriad of tasks, and they know it's not going to come back. And they cost about 100 to 200 pounds each. That's the way the industry is going for defense, certainly on the smaller side. But there are some amazing developments in other areas in defense, of course. If you've got any questions on that, please do grab me. I'm very happy to discuss it. The second one, and the one that we are more focused on, is critical national infrastructure. With critical national infrastructure, there is certainly on the air side, there is a concept called atypical environments. What you're looking at on the screen there is an atypical environment, which means this is an area that manned aviation has no business being. So if you're flying a helicopter and you come across one of these pylons, and you're that low that you can see it at eye level, you're definitely in the wrong place. You shouldn't be there. So this is a relatively safe space, maybe 50 meters either side, 50 meters above power lines, railway lines, pipelines, over nuclear power stations, over defense facilities, over offshore or onshore wind or offshore gas or anything like that, anything that has an infrastructure underneath it. This is a concept which is revolutionizing the applications of drones, because up till now, it has been very, very difficult to commercialize this technology other than inside a building, so inside a manufacturing facility or inside a warehouse. So out in the open, they are very difficult to get clearance or authorizations from the CAA to fly them commercially. Incredibly difficult. What my company has done is created a system which is called digital tethering, which provide assured flight alongside infrastructure such as this in atypical environments, so that you can be absolutely assured that as the drone is flying, if anything goes wrong, it's only going to do one of three things, actually one of four. The first one is it's going to land immediately, safely, set off a little beacon to tell you where it is. The second is if it's a relatively low-level fault, it might be able to get to the next safe waypoint and land, or go back to the previous waypoint. The last one is an all-ditch attempt, or everything's failed, you've lost power, it is literally just going to fall out the sky. Okay, but it is in an area, it is over a corridor which is safe because nobody's walking on it. So it's either side of a railway line or a power line. So that concept is now opening up the beyond visual line of sight market. We're running a trial with a large critical national infrastructure organization that I can't tell you about today, which will culminate in October, and then we'll expand that out. So this is a really exciting thing. It's an infrastructure project, which is what everyone forgets about. It's a really exciting project because it opens up that commercialization concept. It can be used by any air system or any maritime system, and indeed any ground system as well. It just provides multi-level navigation, multi-communication systems, and multi-flight assurance systems. So it's got multiple redundancy all over it. Certified to DO178C. So it's as safe as a manned aircraft. The last sector is commercial, which is where you are. There is a huge amount of work going into the commercial industry in drones. If you think about that sort of ground-based, air, maritime sort of spread of this technology, if you are in a facility which is inside, it's really easy from a regulatory point of view to start utilizing this technology. And there are many organizations who do. It's a little bit tricky with the air stuff, but it's getting easier and easier because of the safety built into these systems, so that if they do drop out of the sky, they're only in an area that's safe, or that they have other systems on top of them that are designed to make them safe. So it's a lot easier for you guys to implement this, really. So the question is, why aren't you? There's a lot of organizations who believe that actually the organizations is not there, the regulation is not there, the technology is there. And that brings me on to the final slide, which is the future. And I'm just going to talk a little bit about the future because it is quite important. Up until now, as I've said, commercialization has been exceptionally difficult, really, really difficult. And there is a lot of reticence. We all believe, we've all been sold the fact that we're going to be delivered parcels to our house by Amazon. It is not going to happen. You're not going to do that. To fill the skies with thousands of tiny little drones is not commercially viable, it's not safe, and it's not socially acceptable. But it has built a fear. I think Amazon's got a lot to answer for. I don't think there's anyone of Amazon in the room, but if you are, you've got a lot to answer for. You've damaged the drone industry irreparably because everyone believes that the regulations aren't there, we just can't use them. That is not true. The regulations are fine, perfectly fine. It takes a little bit of work, a little bit of understanding of what's possible, and build yourself a technology roadmap that can deliver commercially viable systems for your business now. And that can range from smaller sub-250 gram UAS to ground-based systems, no problem whatsoever. So the technology is there, the regulation is there. What we now need is the will to implement. And I hope today you will try and question me on that, because I want you to have the will to implement. And we would love to help you. That's what we do. Excellent. So that's the end of my presentation. I'll take any questions on the panel, or we are at our stand just inside the door outside. Thank you very much.
Well, I thoroughly enjoyed that, and I personally have plenty of questions. But my first question, well, I'll ask you when you're on the panel, is this business about unmanned versus uncrewed. That's definitely sparked my PC monitor. I'm now going to invite our first panel to come and join me up here and take seats. We are going to get stuck into that. I just want to remind everybody, please, as you've just heard, we do want to take as many questions as possible, hear from as many people as possible. So go onto the website, use the QR code. I think it's probably on your screen now, but as you can see, we are ready to start our panel. So I'm going to invite David Grayley from MTC to join me, Louise Ball from BPP University, Kirsty Davis-Chinnock from Professional Polishing Services, Robert Garbett back from Drone Major, of course, David Atkinson from Lloyds Bank, and Rachel Samby-Thomas from the University of Warwick. Ladies and gentlemen, please give them a big round of applause as they take their seats. I am just going to have to ask you, is that a PC thing of saying?
Yes, unfortunately it is.
You can't say unmanned because it's not unfemale or unwoman.
Yeah, well, essentially, sadly, because unmanned has the word man in it, even though woman also has the word man in it, the decision was taken at ICAO to change it to uncrewed.
Oh my God.
I fought it for about 4 years,
Good
but I
for
had
you.
to give up, sadly. So it is now uncrewed, which is still wrong because you can have an unmanned. Unmanned means no pilot or driver on board. It does not mean no people on board. So you could have a larger...
So it can have a human?
You can have humans on an unmanned system, serving drinks at the back or doing whatever they're doing, or maintenance on a large unmanned system. It just has no pilot. So uncrewed is wrong because it can have a crew.
Right. I
So
can. I
it is
know
wrong,
I've taken us down a rabbit hole, but it just. I was just like, what? The PC gone mad.
It has gone mad, and sadly ICAO have bitten into it, and that's where we are.
Well, thank you. I just wanted to confirm my suspicion that this was completely nutty.
It is.
But obviously, we are not here to talk about political correctness. We are here to talk about something much, much more important, and that is manufacturing and the skills shortage. I want to just look back in time a little bit and look back to the sort of 90s and the 2000s and see, was that where this gap started to broaden? Maybe we'll go, well, David from the home team, just tell us, is that when the rot started to set in?
Well, I think what the issue is, my background is qualifications, skills qualifications, vocations. I spent 20 years looking after a vocational skills organisation. If you look at the qualifications side of it, it's a tactically driven system. It's not strategic enough to look at what the needs are of the employees within the system. And I think we've always constantly focused on vocational qualifications being the reform part of the education sector. GCSEs and A-levels have been with us for 25, 50 years respectively, not been touched other than the recent regrading system. And then when you look at the university sector, people understand degrees in universities broadly. In the middle, we've had massive reform in the vocational sector. And in my opinion, the wrong end. We should have put all that money, and it's been hundreds of millions of pounds of looking at different qualifications into frontline quality delivering of teaching. So I do think over the time, it's not just those particular decades you referred to, it's a view that the actual skills equals qualifications. That's too narrow, that's too simple, and it's unstrategic.
Rachel, I saw you nodding there.
Yeah, no, I absolutely, completely agree.
Is Rachel's microphone working? Yes? No?
Shall I just shout?
Oh, yeah, I think that's right, yeah.
No, well, I completely agree. I completely agree with that. I think the education system and the skill system is fixated with qualifications. The reforms to apprenticeships try to address that because they would try to look at outcomes rather than kind of tick box exercises. But even then, they're being kind of overqualified, or whatever the word is. They tried very much to look at it from an employer point of view rather than a kind of educator's point of view, which I think was the right thinking, but actually it's gone too far the other way, I think, because it's the apprenticeships, and I think there has been even though I'm a huge fan of apprenticeships, I think there's been an over-focus on apprenticeships, and the fact that the levy is apprenticeships only is a disgrace. But the fact that the employers are coming up with all the kind of the standards means it's kind of like 1,000 flowers blooming, and they're very kind of long, thin flowers, which I don't actually think is what manufacturing needs going forward. It needs to have people in it who are coming in with a wide range of skills, which are adaptable and agile and can be used in various sectors rather than just being narrowly focused on one qualification.
Kirsty, we're just saying there, what does manufacturing need? Tell us what it's been like in the past 20 years and how things have changed.
I think that the change in apprenticeships has not done most manufacturers any good, particularly in the SME market. If you're looking at being led by the large corporations, I don't need what JLR needs. I don't need my apprentices to learn how to weld. We don't weld. And when you look at manufacturing programs now for apprentices, they don't match what the SMEs need. So 30, 35 years ago, we could take an apprentice on and almost write the program. So they were learning what we needed them to learn. Whereas when we have one now, they go away to college for a day a week and learn nothing that is relevant to our business and nothing that can be brought in because they're given this smorgasbord, in my case, of anything to do with metal, that is just a waste of their time and our time. And it's not about giving them a wide range of skills. It's distracting them almost. I would rather they did less practical things and learnt more about metallurgy and for us then to be able to perhaps move them into a technical side, then a sheer apprentice, it's not fit for purpose for an SME.
Louise, how have we ended up in this situation?
I think, I think government went out to industry because they did a review. They were saying, we want to have an economy that's more like Germany, for example. So let's look at how they do it. And then they put employers in the driver's seat. So they said, you are the people who create these standards. So you will say, these are the skills, this is the knowledge, these are the behaviours that an engineer should have at this level in this job role. But they've become very, very rigid. And I think there needs to be further collaboration. Industry needs to work with education to bring together, it's about having that domain expertise, but as well, the industry is constantly changing. So how do educators keep up?
Because
it's all about collaboration.
It's just interesting because what you were saying there, to a layman, that sounds quite sensible. Government said, we want to be more like Germany and we're going to ask industry, to get involved. Both of those things sound quite sensible because very often the criticism of government is they don't look at what other countries are doing and they don't listen to experts or industry. So actually to my mind, it sounds like they sort of had good intentions but got the wrong outcome.
And they formed the trailblazers, but I just think that the system has become very, very rigid. And as we know, there's no such thing as a job for life now. Innovation is driving change. So how do those standards keep up with the needs of the industry? And I think what we are looking to do, because we need to basically move towards digitalisation, we need to be able to achieve more with less using technology. And it's about creating a workforce that in a skills economy, so they're modern, they are multidisciplined, they're not frightened of the technology. And again, it's all about that collaboration between understanding actually what the industry needs, so frontline workers working in manufacturers, and actually feeding that back to the educators who are delivering these programmes.
Rachel, I saw you wanted to come in.
Yeah, I did. So probably the reason I'm on this panel is not so much because I'm registrar at the University of Warwick, but because I was previously Director General for Business and Skills in what was the Department of Business, Innovation and Skills. So trailblazers on my patch, looking at industry on my patch. So I take credit for the good intent. However, it has been with, so I kind of left government in 2016 and I've kind of watched what has happened since. Now, partly I blame the fact that it was moved in a machinery of government into Department for Education. Because before I left, I had become the shadow CEO of the Institute for Apprenticeships. And even in those conversations with people in DFE, because I know it kind of sounds strange, but each government department has a completely different culture, completely different language, a completely different mentality.
Which is mad.
Which is mad, but it is just the way it is. And the conversations with DFE were already completely different because they were busy talking about qualifications. They were talking all of their education speak, which they are completely fluent in. Now, of course, obviously people in government, they have because it is public funding, though we haven't come on to the issue of funding, don't start me on that one. But because it's public money and you have Treasury breathing down your neck, they are very, very obsessed with qualifications because they want to make sure that actually, the kind of public money is being spent on things which are delivering value for money. But of course, the irony is by putting so much emphasis on it, they kind of squeeze the life out of the qualifications. And by the time they're through them, they're probably already no longer fit for purpose. So it's a horrible, ironic.
I promise I'm going to bring other speakers in, but thank you very much. I've already seen some really great questions coming in, so I'm just going to keep an eye on them as we go through because we've only got less than 20 minutes left. But interesting here, anonymous question already saying, as a former technician apprentice, I must disagree with Kirsty's comments. The first year provides a baseline appreciation of engineering skills and learning, providing a foundation for any sector. So just an interesting comment there. I must broaden this out. David, it's interesting, isn't it? We're already hearing, we're getting a really good idea of what the problems are. How do things look from where you sit, from a Lloyd's perspective?
Yeah, I was reflecting on, well, first of all, your sort of positioning for this session around looking back 25 years. And I'm thinking, crikey, 25 years ago, we were all running around panicking because we didn't know whether computers were going to work in the year 2000, did we? And,
absolutely.
And why not? Because we didn't have the skills to understand the technology. And 25 years on, it feels as though we're almost replaying history again, where we've got modern technology that can really transform the workplace. We've got the capability to become a global force with the innovation and the creation of new ideas and the research and the development, the world-class universities, the world-class engineering facilities that we've got here, and yet we're coming up short with the skills to be able to take advantage of it. And I think when you think, and I know someone mentioned the levy earlier, and I know that there's been an ability to transfer unused portions of that levy. I think it's about 25% of unused levy, but how many big businesses out there pay into that pot and just let it go as a tax? And yet there's dozens and dozens, thousands of small SMEs that could work with institutions like the universities, like the MTC, to create bespoke courses that they really need, that is attractive to the youngsters, and to create a more diverse workforce. You know, there's only about 25% of the workforce in manufacturing represented by women. Only 15% of businesses owned by women in the manufacturing workforce. We don't have enough role models because we don't have the apprentices coming through. So what could we do to broaden the adoption of unused levy to allow industry and institutions like the MTC to create bespoke workforce that really does give the skills to meet the needs if we are going to transform, as I think it was Dell's sort of exponential curve, that almost mirrors the transition of productivity in the UK as well, when you look at those industrial revolutions. And if we haven't got the skills, we're suddenly going to fall off a cliff, and everybody else is going to take advantage of it, and then we're going to end up importing everything like we have done in the past. So,
and can I just add to that? It is an absolute disgrace that the unspent levy money goes back to the Treasury and does not get recycled back into the skills pot.
Why does that happen? How does that happen?
A government accounting rules.
Because it can.
Because
it can.
accounting rules.
So
Because it's fiddling the figures.
No, it's just government accounting rules. Anything every department underspends, they send it back. So most departments do their absolute level best to try and spend every penny they have, but DfE don't. So it goes back.
So large organisations pay into the levy. If it's not spent within 2 years, it goes back to the Treasury, and 3.3 billion was returned. But it's only 3% of large employers who are actually donating the levy to the SME. So Lloyds are trailblazers in that area. But again, you're capped, you can only transfer 25%. But I think, you know, in terms of the issue that was raised around diversity, about attracting a new generation of people to the sector. So there's been since the levy was introduced, there's been a decline in terms of young people wanting to do apprenticeships. So 49% drop from people aged between 16 and 19.
And yet we've had figures out this week showing that the NEETs, the numbers of young not in education or employment is exponentially growing.
Absolutely. But then in manufacturing, engineering and technology, in the last 10 years, there's been a 34% decline in people wanting to do apprenticeships in that sector. And I've reviewed WorldSkills data. They surveyed 1,000 young people, and it's something like 54% of people would not consider a career in manufacturing. So, you know, more needs to be done to basically change the brand of the sector. And I think, you know, we know that the sector is changing, the roles are changing, the skills that are required to do those roles are changing. And I do think that, you know, in the future, as those roles become more sort of akin to like a software engineer or a data engineer or a games developer almost, that will attract a younger generation to the sector.
It's a generational perspective. So you've got young people now whose grandparents might have worked in, you know, really dirty factories. So these young people's children are going, you know, this happened to your grandparents, don't do it, go into something else. And a lot of manufacturing sites are no longer at the end of the road. The factory is no longer at the end of the road. It's on a wonderful part like this. So people aren't seeing it as accessible. They don't understand it. And it's ignored a lot.
And Robert, I'm guessing that that's not a problem you have, because kind of drones are sexy.
No, well, drones are sexy, you're absolutely right. But it is a major problem, actually. Right from, obviously, I'm not a manufacturer, so there's problems that we have with the system is the quality of the training that these people get. It's never, they don't even get time management, so that they don't even kind of manage their day, let alone anything else. So the quality of the training is no good for us. But I do know that many of my suppliers, we have 7,500 suppliers globally in our network, and I know that many of them are struggling to hire people. And since obviously Brexit has caused a bit of a problem for these people, they're trying desperately to get the qualifications, the skills that they need into their business to design, to create, to innovate, to manufacture, and they simply can't get it. They have to bring it in from overseas.
Yeah. So we've had a question here. How do we encourage our ageing workforce who may struggle with confidence around new technologies to participate in learning? So this is the other end of the spectrum. So if, I'm sure we'll come back to how to get youngsters interested, but then we've got, that's a really valid point, isn't it? The retraining side of things. How do we, who's best equipped to answer that question?
I'll start on that, Daisy. I think it's a great question, simply because the workforce we have today is the bulk of the workforce we've got for the future. So the idea the government has periodically of saying we'll take the unemployed, we'll skill them and put them into work, there's just not enough people to do that. So the work that's being done by the Workforce Foresighting Hub, for example, here, identify the skill needs of the future. In one sector alone, offshore wind, for example, they need 70,000 new skilled people in the next 3 years. So we can't just go to the unemployed and request that. And that's a difficult ask anyway for many, many social reasons. So we've got to look at, and this is what we're advocating to the government at the moment and also to potential governments, that actually we need to look at this more strategically, right from, say, 8-year-olds and making them aware at that early on manufacturing is a phenomenal opportunity in terms of it doesn't have the imagery that Kirsty portrayed before. It's very different. But what do we do? How do we transition from currently what we're seeing is declining sectors into the new high growth sectors where we know, for example, the Autumn Statement put £4.5 billion into the Advanced Manufacturing Plan. Most of that is about the technology. An example,
in fact, I'm just going to interrupt. One of our questions is specifically about that 4.5 billion, and the question says, how much of that could be focused to skills and capacity development?
A lot more than has actually been allocated, I would argue. I think the point here is, though, the example we want to, how do we help transition and manage that transition at the right time, right place, with the right skills to help industry grow and scale in those sectors that are going to generate economic growth for this industry. And that's the challenge. So we have the qualifications piece we've talked about. And I do think the levy was being very generous here in an attempt to change a mindset from a cost related to skills to an investment in skills. Don't think it achieved it, but I think I've been quite generous there. So I'll give you a small example. One of the employers that we work with pays their apprentices exceptionally well. We find, therefore, we have mid-career changes because they have that financial safety net of going from, I have a job now, which pays for all the things in my life, a mortgage, etc. I can transition into a whole...
Can I ask you, what does exceptionally well mean, out of curiosity?
£28,000, for example. Now, I'm not going to name that individual
No, just to give a ballpark.
That means that those apprentices have that assurance in their mid-career transition, whilst, for example, they come here for their first year, as that colleague in the audience mentioned, to ensure that they have a sustainable living and they have that financial safety net. Not only the qualification at the end of it, but also the financial safety net when doing it, and therefore transition. We need to scale that. That needs to be a national plan for all sectors.
Yeah, so I'm working on similar projects like that with other sectors as well. So, for example, I'm working with one of the big four supermarkets who are actually doing a reskilling program for colleagues who work in their stores. So this is a career change program where we will pay somebody's salary and at the same time support their transition into a technical role where they need more technical skills. Now, in terms of manufacturing, I think one way to encourage people to reskill is about context. So we know that artificial intelligence, it's a fantastic opportunity for all sectors, and that starts with your data. So you can't have AI without good underlying data, but it's about context. So if you put into Google search data training, there's loads of it out there, but is it any good? It can be anything from Excel, Microsoft Excel, to artificial intelligence developer. But what actually is required for an engineer to do their job and to actually start to implement new technologies within that business. And I think if you get the context right, so again, it's about we teach them the digital skills in the context that enables them to, I think using technology, leveraging technology to basically make us more capable as individuals. And the best example of that is spell check, because in the 90s, I was an apprentice. They just introduced a word processor. And I think we all use spell checkers now without even thinking of it. So that, that's probably one of the early examples, but think about how it enables us to, it just brings out the best in individuals, doesn't it? That's what technology can enable us to do. And I think that is how we encourage our workforce to basically upskill, reskill.
Okay, I just want to move on to what the next couple of decades might look like. We all know we're in this, things are changing so fast, so it's probably hiding to nothing to try to predict. But one thing's, obviously we know automation, we've already heard how we're falling back on robotics in this country. But just what would the training landscape need to look like for the next couple of decades? I guess that's Louise. Is that you again?
I mean, there absolutely needs to be collaboration between educators and industry. I've worked on similar projects in the past where, it was a project that you were involved with, David, funnily enough, in a former life. But there was 2,000 job vacancies. It was for the technology, digital sector. And what was preventing their growth was not enough people within the sector. And we formed together to collaborate. So actually, how can industry inform the curriculum? So, and then we basically developed that skills. And as a result of that project, we created 200 jobs.
But what we have to, the context we're working in is a huge educational system, basically. And therefore, any government's ability to change it is really difficult. Now, that's a great example that Louise gave, where we came together, we collaborated, and we were allowed to have the flexibility to do what I needed for my business at that time. The organisation that Louise worked for provided that for us as an expert training provider, and government funded it. That's the tripartite relationship we need, which bespokes it for Kirsty's needs, it bespokes it for the MTC needs, it bespokes it for Drone Major's needs. The problem we've got, it goes back to Wendy's point about the measurement of the value. So you've got a case of here where the government have said, how do I measure that value? And it's always defaults back to qualifications. And therefore, we need to look at a different way of making sure the skills input in that tripartite relationship.
David?
Yeah, can I just also think about the SMEs in this, thinking of what Kirsty said earlier. The whole supply chain in the UK is totally reliant on the SMEs. You cannot survive without the SME supply chain. It's about 98% of the UK economy. It's the absolute backbone. And there are some really simple things the bigger supply chain partners can do to help the smaller businesses. The small SME, they have to try and do everything. They have to think about innovation. They have to think about technology adoption, integration, training, marketing. They don't have a separate team. They don't have the resources, the cash reserves, to just take a punt on some of this stuff and think ahead. Sometimes they just have to act in the moment. But I think if the OEMs and the bigger supply chains realise and just take a step back on how important the SMEs are, and then when you look at how tight the labour market is and is likely to continue, there is small things and small steps that can be taken in those supply chains through collaboration, where some of the bigger industry players could actually help and demonstrate how some of this transition can actually make a massive difference
you're
to those
echoing
small businesses.
Quite a lot of the questions. So the question here, I mirror Kirsty's thoughts. SMEs need different training from the OEMs, engaged with smaller business, says that question. Another one here. Where's it gone? What does she want? This is a question for Kirsty. What does she want in skills support as an SME who's pushing to grow? I mean, I think you've probably set out some of those things, but
I think one of the things it's great to hear about advanced engineering and advanced manufacturing on everybody's lips at events like this, and hearing the government starting to talk about it. But advanced engineering and advanced manufacturing won't happen without bog standard basic manufacturing. We need metal bashers, we need people creating all sorts of things to then get it into the advanced sector. So what we need is to be having a seat at the table. Half the time we're not. but we're still in the supply chain and it's very difficult. But with regard to skills and trainings, we need to be able to work with the people who work with us and see what they want. Because some people want to come to work, do their job, do it very well, learn new skills, but they don't necessarily want the qualification. They might not necessarily be able to have a qualification. I have someone celebrating 30 years with me, because we do still do Jobs for Life this year, who started at 15 because he is very dyslexic and couldn't take his GCSEs. He's senior in our organisation and brilliant at his job. These people need to be recognised as very talented, even without the qualifications.
And what's the role, do you think, for VR and AR with apprenticeships or training or skills? I mean, I sat in a presentation last year at the massive technology conference in Saudi Arabia, and it was all about how certain, VR and AR will be doing the training for manufacturing jobs in the future. And it was very impressive, but I had no idea whether it was accurate or not.
I think when it comes to standard manufacturing, there's a lot of things that AR and VR can do with regards to looking at developing, in my example, new finishes or new applications, looking at potential problems. As someone who's got two machines next to each other that are identical, that side, and the machines like doing different things. Machines have a mind of their own, and you can get as advanced as you like, but mechanics do still come into it. So I think there is an application there. I think that SMEs aren't going to take it up as quickly as we should. To things that David mentioned earlier, that we don't have the time, the bandwidth, or frankly, the money.
All right, we had a question here. To Louise's example, trade bodies, now I don't know how to pronounce this, is it Gambica? Is that right? Gambica. Have a university and industry collaboration group which helps bridge the gap, but it's not as publicly known about. We must raise awareness of initiatives like that. Yeah, agree with that question.
Yeah, and so just on that, because we've collaborated, I work for a university, we have a School of Technology, we've collaborated with expertise from the MTC to give it that context. So, I think it's about bringing the two domains together. The keynote from Dell mentioned about taking a time-served engineer and giving them those more, advanced kind of digital skills. Future-facing skills.
I'm going to read out a few questions because I'm very aware that we're running out of time. So a question here, industrial innovation is accelerating at a rate never experienced before. How can academia remain relevant and keep up with the real world? So I'm going to ask our academic representatives to bear that question in mind. We'll do it. We'll summation everything. Trying to set up an additive manufacturing apprenticeship was informed the trailblazer needs to be driven by industry. Surely AM specialists and academia also should be involved due to awareness. Okay. What steps have you taken to make the issue around the skill gap we have now won't happen in the future? That's a biggie. Is ageism a barrier to employment in manufacturing? I think we've slightly covered that already. How can the industry attract new talent when the press only report negative news? All right. If we unlock the unspent levy pot, and again, we touched on the unspent levy pot, but this question says, to fund transport and hardware, software for apprentices, that would create more placements. I'm basically going to give you the opportunity to answer any questions that you think are relevant to you. I think we've covered that one. What about training and development rebate, not just R&D? In theory, you could then train someone from any background or industry and get rebates on salaries, training, costs, etc. Okay, what I'm going to do, and I'm going to run over by a couple of minutes, I'm going to start at this end, and I'm just going to give you each an opportunity to answer any or of those questions that you think are most relevant, and then we'll call it a day, Robert.
I'll be very, very quick. One thing that people may not realise is that about 75 to 85% of the drone industry are very, very tiny little companies. They may be manufacturers. There may be 4 people in a room assembling a high-tech piece of equipment. They really struggle with these things. They cannot get the skills that they need. And of course, they're very short across the industry. So they're, when someone leaves one company, they're immediately swallowed up by another
fighting
company.
over the same people.
So training, the ability And I'd really love to have a conversation with the MTC on developing something for the drone industry, because it is a manufacturing role, but it is a technology development innovation role. So understanding how, for example, an unmanned air system works technically, how you reprogram it, how it does, that is a really core skill that is lacking in the industry. So I think there are things that we can do with organisations like MTC, with an organisation like Drone Major or the Drone Delivery Group, to bring those two bits together, because I guarantee you those organisations out there don't know they exist.
Rachel.
So I think if we're not going to be having this conversation again in another 10 years' time, I was having the same conversation 10 years ago, we need to completely reform the skill system. We need to strip out all of the unnecessary rules. We need to make it much more simple, much more user-friendly, and much more agile going forward. I think we need to look at funding, because we haven't really talked about funding apart from the levy, but it's been absolutely stripped bare from adult skills. So we need to look again at funding. And that includes the use of the levy and making it much more versatile. And I completely agree with the conversations about everything needing to be in partnership and collaboration, and that's between academia, between industry, and between FE, which we haven't really talked about as well. And we need to look at it on all layers. We need to look nationally, regionally, locally, and we need to look across sectors. Huge amount to do.
Not much to do then. David.
I'll just reflect back again on the SMEs, and I make no apology for continuing to support that message, because they are the backbone of the sector and the economy. And there are some really, really innovative, amazing SMEs out there that have invested in training, technology, bringing new skills through. And I would just encourage those that haven't to seek out the help and advice and guidance and support, both in the supply chain and through academia and amazing places like the training centre here.
Yeah.
There is a way. But sometimes they just need the help and the support to do it. But if they explore, I'm pretty confident people will be willing to help, because they know how important it is.
Lovely. Louise.
So I think I'll tackle the question about how we attract more people to the sector when the media are very negative. And I think it starts with employers need to create the opportunities. So I think reskilling, take people from other sectors, support career change programmes. That as well, I know that, obviously larger employers have got more capacity to do that, but then they should then collaborate with SMEs within their region who can then lean on them for talent. Let's collaborate, let's put placements, and I suppose if there's a large employer, there's one in the Northwest where I'm from, will recruit 400 apprentices a year. Not all of them will be taken on. So actually collaborate with the SMEs in your region who can then, I suppose your supply chain can then recruit from that pot of talent. But I would say as well, look beyond the people who've just left school. Let's look at the people who are in other roles within your business that we can then retrain to do roles within manufacturing and engineering.
Kirsty.
I think the future is going to be really exciting for manufacturing, and SMEs play a huge part in that. I would encourage all SMEs to talk to local universities. You can quite often do small projects, get started on looking at a bottleneck, looking at how to improve something. And you can quite often do that for little or no money. It can be free. It's just going to take your time. And once you start on those journeys, it's amazing just what you can achieve to improve your productivity. And to improve the knowledge that your team have, and they'll learn new skills. So that's something that we found really, really, really invaluable.
Yeah, great. David.
I think we are at a real pivotal time. We've got an election coming this year, and therefore taking the Advanced Manufacturing Plan and looking for a strategic skills advanced manufacturing plan would be from 8 years old through to exiting. And at that point, not even stopping, but be coming back into the sector as meant to support it and everything in between and looking at it and realising there is a three-way conversation here. There is the educators, there is absolutely very much industry, and government is a huge driver. So we were alluded to tax credits before for training, for example. Now, the Labour are thinking about that as part of their current manifesto thinkings. Ideas like that to encourage all businesses, whatever size, in the supply chain, to think of training as an investment and not a cost will massively change the outlook in terms of the culture and the opportunity we have to attract people into this phenomenal sector, to be honest
Yeah.
with you.
Absolutely. Well, apologies that I've run over by a couple of minutes, but I think we had so much ground to cover, and I think we did cover a lot of ground. As I invite the panel to leave the stage, ladies and gentlemen, please give them a show of your appreciation. Okay, well, there was some mention about the important role of government in that panel, of course. There needs to be collaboration with them. So it's very fitting that we are moving on to our next political speaker of the day, and that is Mark Pusey, to give the government's point of view.
Good morning, everybody, and my name's Mark Pusey. I'm the Member of Parliament for Rugby. Now, many of you might have thought you're in Coventry. You're very close to Coventry, but you're in Rugby Borough and Rugby Parliamentary constituency. And I'm very proud that Anstey Park is within my constituency, because I've been delighted to see, since I was elected in 2010, Anstey Park grow as a hub for manufacturing. And as a member of the Business and Trade Committee, and also the Energy and Net Zero Committee in Parliament, and I'm also chairman of the All-Party Parliamentary Group on Manufacturing, I've been delighted to see how this place places a real focus on the need for the UK to remain in the position that it's got as a centre for manufacturing. My constituency has a core of manufacturing. We're in the middle of England and at the heart of the motorway network, and so it's inevitable that logistics features pretty prominently in our commercial base. But I think it's really important that we continue to maintain the UK as a manufacturing hub, and particularly in the areas of advanced manufacturing, in the quality of the things that we make here. I want the UK to remain important as a place where things are made. And one of the ways that we're going to achieve that is by continuing to innovate in the way that we do things. And the MTC is a great example of how new ideas that are applicable in one area of manufacturing are being implemented across the manufacturing piece. And I want to see that continue. And of course, for us to be able to do that, we need to have a workforce with the right skills, and that involves upskilling the workforce and continuous training. People, we seem to spend too much time for people go to college, get a qualification, and assume that that's it. We need to continue as innovations come along and new ways of doing things materialise. We need to make certain that people improve and enhance their skills. And it's so important that we see the UK at the forefront of this technological change, and that the UK continues to present a face to the world as a centre for innovation, as a place where innovative things happen. And I'm so proud that that's happening in my part of the world, here in Anstey Park. It's great that so many of you have come here to Rugby to get involved in the National Manufacturing Summit, to talk about how we grow and develop our manufacturing sector, that you'll get involved in so many conversations. I think in addition to the formal events, the networking that many of you will have in meeting one another and exploring these ideas will be tremendously important. I wish you all of the best for a really exciting session ahead.
All right, well, our thanks to Mark Pusey. That brings our first session to a close. I'm afraid it's a rather brief coffee break now. So it is, I'm afraid we are coming back at 11:20. So grab a coffee, whatever it is that you need to do, and we'll be back for our pre-lunch session.
Just hold on.
All right, ladies and gentlemen, I'm sorry to rush you to take to your seats, but we are going to start again now. I can hear that outside there telling people to come in, but I'm very aware that we have so many fantastic speakers to get through today that I just don't want to make us overrun, because also I'm very aware that some of the networking is really, really important. So I want to make sure that we've got enough time over lunch and throughout the day that people can chat away from the stage setting. But thank you so much for joining us for this session. Obviously, we're going to go through, got a panel, got a couple of speakers between now and lunch, and then more time for more chat over lunch. But right now, we're going to have a talk on the evolution of automation. So please give a very warm welcome to David Barrett-Haig.
Good morning. My name is David Barrett-Haig. I am the Head of Marketing for Industrial Automation at Schneider Electric. And I've been asked today to provide an overview of what the future looks like for the innovation and technology in the manufacturing sector. Now, to quote Niels Bohr, prediction is difficult, especially when it considers the future. If I was standing here 30 years ago, would I have predicted the birth of the World Wide Web? An innovation so profound, it's changed everything about our lives. So I'd like to start by making the distinction between technology and innovation. Technology invents things, but innovation really transforms the way that we actually live our lives. Tim Berners-Lee didn't invent the computer, networks, graphical interfaces, or even hyperlinked pages. But by combining them together, he fundamentally changed the way we work. The rest, as they say, is history, which is actually a great place to start. We are all familiar with the history of the Industrial Revolution, when companies like Schneider were founded, driven by mechanization, powered by steam. This was the transition from making things by hand to making them by machines, which we would typically call today the start of manufacturing. These machines got increasingly more sophisticated as we moved into the technology revolution, characterized by mass production. This is when Henry Ford, who cited as the inventor of the moving production line, coined his phrase, "You can have any color as long as it's black." Does anybody know why you could only have black? No. Japan black paint was the only paint that could dry quick enough to keep pace with his production line. So importantly, though, this second generation is really about where the electrification of manufacturing came in and the invention of the induction electric motor. Oops, sorry. By Tesla, actually. And in fact, 100 years ago today, Schneider invented the contactor to safely control this device. Motors, which actually consume a half of the world's electricity. This then was the start of what we'd recognize as automation. Although it really starts as we move into the information and the digital age with the birth of computers and integrated circuits. As we enter this third industrial revolution, Schneider Electric was again at the forefront with the invention of the PLC by Dick Morley in 1968. We had a programmable computer system dedicated to process control and then to meet the needs of manufacturing. Now, technology moved at a pace in the following decades to what we refer to as oops, not doing this very well, as the Industry 4.0. Now, the technologies around 4.0 are characterized by the Internet of Things, which was actually invented in 1982 to monitor Coke in vending machines. Robotics, these were first commercialized in 1954. And artificial intelligence, arguably invented by Alan Turing in the early 80s, but expert systems then became successful. But the innovation that really defines this fourth industrial revolution is the digitalization of the manufacturing process. This cyber-physical system where data is collected and used to not just control, but to actually improve, where we're turning data into knowledge to identify actionable tasks to improve the process itself. The resultant data-driven approach, also known as smart manufacturing, And at Schneider Electric, we not only provide these solutions, but 8 of our own smart factories are classed as Lighthouse by the World Economic Forum. So what have we learned from this gander through the history of automation? It's clear that technology will continue to improve. They become faster, more agile and capable. The one thing about that all-important innovation that will shape this world. And there are 2 elements, I think, that where automation has involved, which can give us a steer. Throughout history, manufacturing engineers have taken technologies, adapted and developed them to their challenges. In the past 25 years, we've seen a massive move to adopt aspects of information, IT, into this operational technology space, OT. Modern manufacturing processes are managed by software, currently written to run on a particular hardware platform. However, an open, interoperable hardware environment is the norm in the IT world, where hardware can be seamlessly migrated, virtualized, without any software modifications. Unfortunately, this isn't the case today in the OT world, the automation world. It needn't be so, and the answer to this issue already exists. Schneider Electric has joined a consortium called Universal Automation, where we champion a different approach, where you can automate your process before deciding what hardwares. So it doesn't matter whether it's a PLC, a virtual, an industrial PC, or just a virtual server, or even actually a Raspberry Pi. You can choose at the integration. So this effectively makes the software hardware agnostic. So just think about that for a moment. Schneider Electric, who invented the world's first PLC, is now ready to make them obsolete. We see in the next 25 years, a software-centric universal automation approach will become the norm, utilizing object-oriented design, which will allow app-like approach to the building of automation. Just like today, when I plug a device into my laptop, it automatically downloads the driver and starts to work. And same with our new machines, as we bring them to our production lines, we plug them in, they will automatically work to our systems. But of course, this will be done before we even purchase the machine. In your digital twin, the proposed new machine can be evaluated in this virtual environment, so you can actually virtually try before you buy. The other element we learn from history is that innovation occurs when technologies are integrated together. As I mentioned, Henry Ford didn't invent technologies. The first moving assembly line he basically relied on ropes to drag the vehicles through his production line. Apple didn't invent the mobile phone, the digital camera, but what they did is by utilizing it and bringing in the concept of apps, they very much revolutionized the process. So as we digitalize our organizations, we will link these to our supply chains, our production environments and customers in this seamless ecosystem with AI sort of optimizing how it all fits together. This will combine the physical and digital worlds, transforming how we design, manufacture and interact more than just a simple digital twin. By bringing digital models and physical data together, we get a unified operations center where we can explore every aspect of our organization to solve problems and optimize. We see today this in the AVEVA UOC, bringing together all an organization's data to provide a single source of truth. This is referred to as the enterprise metaverse. But what is that?
Everyone's talking about the metaverse, but what does it really mean? Let's play What If. We'll start. What if this metaverse could bring power, process, and building data together in one location? One kind of data for the whole of your company, for professionals and industry. What if you could see your data working in real time, all the time? What if all the data you needed from your enterprise systems came alive in the cloud? What if, before you did anything in the real world, you could build a digital twin and predict outcomes? Not just that, a process twin, an energy twin, an electrical twin, to design, build, operate, and maintain. And what if the operational cycle was a closed loop, where what we learn from one phase lets us improve the next, and the next, and the next, making you more efficient and sustainable across domains? How about this? What if people could always be trained virtually? It would be safer. They could access it and collaborate from anywhere, and they could learn to be prepared for any possibility. What if you could pick and choose the specific services and expert support you need when you need it, and just pay as you go? What we're saying is, what if there was one experience, one open platform for all, where you could connect all of your devices and IoT systems to unlock limitless potential for power, buildings, industry, and infrastructure? Potential that can transform businesses and even help transform the world. Welcome to the Enterprise Metaverse.
So to summarize, what we do know about the future is that people will be vital and skilled people will be invaluable. And that's why we've expanded our apprenticeship schemes, and that's why we champion the EDI principles, so they get a diverse experience and background, because we know this helps benefit teamwork, creativity, and problem solving. So however automated the future is, it's the people, the innovators, that will drive the process, not just the technology. Thank you.
David, thank you very much. I'm going to invite you to take a seat on the panel, because you're joining the panel session next, aren't you? And I'm going to get Mike Wilson to come and join me up here to explain a little bit about what the next panel session is all about. We're going to be discussing is automation, there we are, panel discussion, is automation the answer to the skills crisis? So if Mike Wilson comes and joins me now, I'm going to pose a question to him, but let's get all the panellists, while Mike and I have a quick chat, to come and sit on, David, to sit there, because I'm handing over to Mike, but I'm going to pose that question briefly to you, Mike. Is automation the answer? Is it the be-all and end-all?
I'm sure it'll be one of the answers. It won't be the be-all and end-all. And we're hoping to address some of that in the next few minutes. What I'd like to do is just kind of set the scene, as it were. One of the issues that we face in the UK is that we're not a great user of automation. We are behind the rest of the world. I'm not going to bore you with lots of stats, but one of the key stats that we do measure is robot density. It's the number of robots per 10,000 workers. It's a relative measure, therefore, and we are currently 25th in the world, despite being the 8th largest manufacturing nation. So we're significantly behind many of our major competitors. One of the challenges, therefore, is should we be using more automation? Is that the answer to some of our current problems? And we're going to explore that a little bit as we go through the discussion. I think one of the points I do want to make, though, is automation is much more than just robots. It can be a simple conveyor. It's principally about taking away the human labour from the task. We tend to talk about robots because you can measure those, you can count them, and therefore it's a good proxy. And one of the other issues, particularly, is a lot of automation has been developed for high volume, dedicated manufacturing facilities, and it's very efficient at that. Things like tea bags, for example. But a lot of our manufacturing doesn't produce high volume product. We need flexible automation, and that's where the robots tend to come in, because they are the ultimate, if you like, in terms of flexible automation. And therefore, when we look at the numbers of robots and how many we have in use in the UK, it is an important measure. So what I'd like to do... I'm going to
leave you to it and to introduce your panel, but sounds fascinating.
Thank you. So if we start, obviously you've met David before, so we'll skip David with all due apologies. If I could start at the other end, if each of the panel wouldn't mind just introducing themselves very briefly, that would be great.
Sure. My name is James Selker. I'm the CEO of the Manufacturing Technologies Association. So we're a not-for-profit organisation, and our members consist of primarily the technology suppliers that make manufacturing happen at the beginning, so engineering based. And we work really closely with Mike at the MTC, sits on our board, and we are passionate about accelerating the adoption of the latest technology, including automation in the UK.
Thank you, James. Oliver?
Yeah, Oliver Selby. I'm head of sales at Fanuc UK. Fanuc, globally one of the world's largest robotics and automation manufacturers, suppliers to industry. From my personal point of view, I'm very, very passionate about the skills and education piece, making sure we've got a workforce in the future that can actually adopt robotics and automation in the right way.
Rosa?
Rosa Wells. I work at University College Birmingham. I'm the FE Principal and the Dean for STEM. So University College Birmingham is both a university and a college. I look after the FE provision across all of our sectors, but for engineering I'm responsible from entry level right the way through to postgraduate, so it gives me a really good oversight of the whole gamut and the whole remit of what we need to develop. I also sit on the board of directors for our regional Institute of Technology and on the national network for those, which work very closely with the Manufacturing Technology Centre. And I recently joined Engineering Council's Education and Skills Board as a deputy chair. So really interested to see what we can feed into Engineering Council in terms of how qualifications or skills development needs to adapt to meet the sector's needs.
Thank you, Rosa. Paul?
Paul McKnight from Vector Robotics. We're an educational robotics company. We work with students from as young as 4 or 5 years old, right through to university. We work in the classroom, but we also support an extracurricular competition, which develops a lot of the skills that we hope industry is looking for.
Thank you. And David, very quickly.
David Barrack, Schneider Electric. So we do a lot of industrial automation, robotics, the controlling software, that sort of thing, as you saw. Enterprise Metaverse.
Great, thank you. And if anybody has any questions or questions online, we're very happy to take questions as we go. What I wanted to do really, though, is start with the labour shortages that we currently face, the skills crisis that we currently face, and sort of really touch on how has technology advanced over the last 10, 20 years, particularly with more intelligent automation solutions and robotics. What's changing, and how is that then going to influence the adoption of those technologies? So perhaps we could start with Oliver in terms of what's changed over the last 10, 20 years.
Yeah, I think it's a really good question, because the core of the robotics offering, the main robot, the controller, hasn't really changed a huge amount. Robot families have grown. We've got smaller payloads, larger payloads, higher speeds, for example, as technology has improved. What has really changed is the way in which the tools that work alongside those robots have developed. So more intelligent vision systems with AI capabilities. We've seen the advent of much better simulation tools. So that's really what's changed, allowing it easier to look ahead at what those future systems may look like, how we can de-risk them as they get implemented into production lines, and how we can look at, say, some of the after adoption tools, which things like predictive maintenance tools, that sort of thing. So there's a lot there that have worked or have been developed as a sort of parallel to the robotics being adopted.
No, thank you, Oliver. James, in terms of those changes, what do you see how the skill sets are changing in industry? Is it having a positive impact in terms of replacing skills, or is it generating other challenges?
From where I'm sitting, which obviously isn't as close to the front line as I would like it to be, I think that there is the most amazing opportunity. And I'd like to actually point out potentially a bit of a gap. We did a study with Lloyds Bank some years ago that identified the biggest barrier to adoption of technology in general in manufacturing was actually the skills in which to acquire and deploy that technology. And I would like to include in that leadership. We've heard about the SMEs being the backbone of UK industry, and indeed they are. But by the nature of their size, they're often limited to looking at close operational issues, getting the next order in and the current order out the door. We've all been there. And that help from all over the MTC and also obviously the technology suppliers have been working hard to make that easier and easier, to make it not a no-brainer. Despite the increases in interest rates, I don't understand why everyone hasn't completely re-equipped their factories and made them totally automated. With the power of technology these days, with the help that's available, say the catapult centres are brand agnostic, so you're not going to be sold to when you walk into a centre like this, and they can put you in touch with the right suppliers of technology. And part of our remit is to put together the national show in this area, which is coming up very shortly in the NEC, called MAC in April 9th to the 15th, where we've actually invested with the MTC in a knowledge hub to allow people to come along and say, where are the immediate opportunities for me to start that journey if they're not already on it?
So just going back on that point, do you see it then as a leadership challenge, more of a project management challenge, more about awareness of what the technology can do rather than the skills to actually utilise the technology?
All of those things, I'm afraid, Mike. Sorry, I'm not going to say yes or no. I think as with anything, it depends on where a company is in that stage. But I anecdotally see just a lack of, not a lack of bandwidth, but a lack of ease in which to be able to just integrate this technology in a low risk way, because the Achilles heel of every SME is misinvestment. And if they see something big, bright and shiny that's going to potentially break them if they make the wrong investment, they're almost certain to delay.
Yeah. David, you got any views on that? I mean, obviously you're representing a supplier of the technology. Do you see a reticence from the customers?
Yeah. And it's interesting because, starting that digital journey, I think, is where a lot of companies do struggle. And, I do a lot of work with helping companies with their digitalization and all the rest of it. But it's just finding that one project. I think Kirsty on the earlier panel mentioned this. Find a problem, get some effort in, and she was talking about bringing in, MTC's universities to help that, but and focus on that one problem, because then it gives you the confidence and the return on investment to then do it again. But to your point, it also raises the value of that within the organisation. I've already had conversations today where people have told me their boss or their CEO is blocking this sort of technology, and it's about training them, learning them, and piloting stuff is a great way of doing that, because it's low investment. You're not going to break the bank over it, but it also then solves your problems.
Okay, so we're kind of saying that the adoption is being slowed because the businesses don't have the skills to adopt it.
And lack of confidence.
The confidence.
Yeah.
But that doesn't necessarily go to the question, as it were, in terms of, is it the answer to the skills crisis? So of the three of you, anybody got any particular views as to how automation could address our current skills gaps?
It's an answer, but it creates another one, isn't it?
Yeah.
I mean...
And that's the problem, David.
Yeah.
James, I think you...
100%. It's a massive part of the solution. It's not the total solution. I consider myself very lucky to be living in this era of such exciting technology where genuinely we're getting so close to viable manufacture to demand, which has so many positive connotations. It's not true. It's great.
Just maybe then touching on or going to the pipeline of talent, as it were, because it's obvious that we need young engineers coming through the system. So Rosa, maybe start with you, but one of the challenges is how do we get the younger generations into manufacturing? And do we see automation as a vehicle to help in that respect?
Yes, I think it really is a good vehicle to help. I think it's a huge challenge. It was mentioned earlier, the brand, particularly of manufacturing, engineering broadly, but manufacturing has particular issues in attracting young people. A lot of misconceptions, a lot of bad news stories, as we've heard. So you've really got to excite young people in terms of what it could be that they can get into. So just as an example, we've set up, as I mentioned, the Institute of Technology in the middle of Birmingham, and we invite schools in to see our learning factory and to work with some of our robotics and automation equipment, so they can see a different side to engineering, to maybe what they thought it was. But talking as part of that sort of remit and that role, we've talked a lot with schools across Birmingham. Obviously, Birmingham's a pretty diverse city, and we know some schools engage really well in STEM and outreach and looking at supporting their learners, and others really struggle. And we've got to make an effort to bring all those schools with us. I find I'm battling a little bit with the concept of the term STEM. And I think it's something we do need to keep looking at. I'm not sure whether it's helping us in engineering. I think the E gets lost a little bit with schools, and I think it's something we need to reinforce with them. It's much easier for them to engage in science and maths and even to some extent technology. The engineering is the challenge for them in terms of school teachers and careers advisors really understanding what engineering is, what does it look like behind those factory doors. And so we've got to do more to help schools to really engage and understand what the opportunities are.
So we, if you like, have a role to play to go out to the schools to try and educate them, as it were.
Yes, but I know it isn't easy, and I think that STEM outreach space is really complicated, both for employers and for schools, which is why through the Institute's technology, working with the Catapult Network, really looking at how to broker some of those relationships and signpost to opportunities to help sort of get through that web. There's wonderful companies out there and organisations offering great opportunities for young people, but they don't always link up, and then we don't always follow them through to make sure we see an impact for those young people so they can keep following on that journey.
Yeah. So Paul, I mean, maybe you can describe what Vex Robotics does, but I know that you're heavily engaged in terms of helping school children get interested in engineering through using robotics as a vehicle to do it. So perhaps you could explain how that works.
Yeah, absolutely. And picking up on what Rosa said there, engineering is often that missing piece in STEM. And it's difficult because, you know, if you look at schools and if you look at design technology as the subject area that is most obviously linked to engineering, in 2009 there were over 280,000 students sitting the GCSE. Last year it was just under 88,000. So it's a fall of almost 200,000 students who are not going down that potential career path. So I think that's the big things where industry can help education and really contextualise what modern manufacturing, what automation, what robotics actually is. And as Mike said, the Vex Robotics supports a competition where we set an engineering challenge. It's in the form of a game. We give teams a restrictive kit of parts that they need to work with, and they need to solve that challenge, and they need to research the game, the strategy, they design the robot, they'll use CAD software, they need to code the robot, and then they ultimately compete at regional events, leading to a national final. Mike was at our national final in Telford a couple of weeks ago, and from there on to the World Championships in the US. But what the students are seeing and experiencing in the competition is, yes, they're developing some core academic skills, but it's really the transferable skills and the skills that the World Economic Forum are saying that industry needs in the 2030s, 2040s. Critical thinking, problem solving, being able to use digital skills. Digital literacy is a huge thing. There's been lots of reports coming out that, you know, if students don't have that level of digital skills, then they're going to be at an instant disadvantage. So, I think, is automation the answer to a skills crisis? As you said, there's more to it, but I think one part of it is industry working more collaboratively with education to try and make more of a contextualised approach for students so they can see what a career could look like.
And from a personal point of view, I'd just like to add that I was there and I witnessed the children that were involved in this, and it was primary school as well as secondary school. And robotics is one of those technologies that gets the children excited, gets them interested, and therefore it's a great vehicle in terms of getting people onto the STEM journey, as it were, and hopefully to produce lots of engineers, not necessarily lots of robot engineers, but lots of engineers out the end of it. It's something that we definitely need to do. There's one kind of topic, and I'd like to go to Oliver on this one, but one of the issues that we certainly face at the moment is some of the more traditional trade type skills, welding, painting, those kind of things are becoming very difficult to recruit people for, because we're not training people the same way that we used to. So Oliver, from an automation point of view or a robotics point of view, do you see robotics helping in terms of replacing those kind of skills?
Yeah, not necessarily replacing completely. I think there's still a need there within certain processes and certain tasks and applications to retain the skill that a human has. So welding, for example, you can hear and you can see and you can experience what a weld is doing when you're actually in that process. You can take a lot of that and put it into databases and let AI take a crack at it. But a person may still be needed. I think where we see the future with robotics is that one robot or also one person could take care of multiple robots if it's done in the right way. So one of the things we're working with there is, say, for example, collaborative applications. And you may think that collaborative applications or collaborative welding, if you like, is not something that you actually want to put in the open, but actually it is. You can have collaborative or robots working collaboratively with lots of robots doing the same task with a single operator who's fully trained and fully understands the process, looking after them all. So there are ways in which you can take things forward, but you I still think you need to maintain the skill level in a person.
Yeah. So it's about maybe if you've got limited people with those skills, making sure that they're doing the jobs where you really need the skills, and where you can automate it, and therefore you give those workers the more interesting, the better jobs.
Yeah. I mean, robotics typically take out the dirty, dull, and dangerous jobs. Yeah. So or support the reduction of those people in those particular jobs. So okay.
So David, a quick question then. Do you see greater use of automation as a way of replacing those mundane, simple tasks that maybe people shouldn't be doing anymore?
Oh, completely. Yeah.
And use the people where their skills add value.
Yeah, and I think that's why the manufacturing environment is becoming increasingly attractive, because those dangerous operations are no longer being done, and therefore the individuals have to skill up to do the more value-add things. I think being a manufacturing engineer now must be brilliant, because you can play with all these interesting things. So we talk about automation like robotics, but actually it's process automation as well. It's actually what's happening, and so they've got all these tools. They can play with AI. They can become a data science. There's so many options they can go from simply just designing a production process. So I think as a career, it can be really attractive. I think the challenge is to let the secret.
Yep, very good. Daisy, we've got some questions.
We've got lots of questions. Do you want to look at them, or do you want me to have a look at them? There are lots and lots. So thank you very much, everybody.
Yes. James, how can SMEs engage with automation when running very low volume with low investment constraints? That's something of a challenge.
That's a great question, whoever that came from. We all have in our mind's eye, or probably many of us have in our mind's eye, it's only worth automating if you're dealing in volume. About 10 years ago, when I was still in industry, or just over, there was a small SME up in Lancashire that spent its entire turnover on automation, and it was a subcontractor in small to medium volumes around a family. Now, admittedly, they were on mainly prismatic components, so they could use horizontal milling machines with tombstones, centralize and do basically FMS. But the opportunities to automate intelligently around small to medium volumes are absolutely there, and there's many examples of that.
No, thank you. One of there's lots of great questions on here, and I'm sure we're not going to get to them all. But one of the questions on here, which I think is important, is why do the panel think that the UK is lagging behind other nations in the adoption of automation and robotics? And then related to that, there's been lots of things like Brexit, tax support, all sorts of other issues that would potentially make it happen, but hasn't yet. I was going to start with Oliver, if that's all right, James. But
yes, I think culture is a big one. I think we've got this long-standing culture that we'd rather keep a machine running rather than invest in something new that's going to be more efficient, more productive, and do it that way. I think that culture is slowly changing, and I think with the advent of, say, Generation X and Generation A as they coming through, that will change, and we'll see more and more adoption of automation because they won't want to do those dirty, dull and dangerous jobs. They'll want to obviously use robotics and automation to their advantage. So I think the culture is a big one where, and we're probably at that turning point now where we do see that those in decision-making responsibility within their businesses are sort of starting to think about it in more manageable ways. If we look across to our European, our global competitors, likes of Germany, Sweden, the US, they probably went through this probably 5 or 6 years ago, where actually their adoption and their ramp up of automation usage has really changed as the culture has changed within their outlook for their business and the way they want to do business globally.
Did you want to add to that, James?
Yeah, at the risk of repeating, for me it's about culture, but it's a wider thing. It's the careers people including parents, who think that engineering is a second-class career, and so they all want their genius offspring to either go into the city and make loads of money, or be a lawyer, or be an accountant, or whatever. And this belief that's in the past, in the 70s, where we used to expect people to buy rubbish that was made here, is massively changed. And people like me are not doing a good enough job getting across the message to the wider public about what an exciting and important strategic area manufacturing is, particularly for the UK. In fact, again, working with Lloyds, we've produced a report that shows that the UK manufacturing contributes 23% of GDP. And so as a multiplier, there's no better sponge for the amazing innovation that gets created here. And if you are putting it into hardware and then exporting it, it don't half well help wealth creation, as well as, of course, supply chain resilience. And the really exciting thing is that the technology is very nearly here to be able to do most of that. If you believe the factory of the future is actually going to be able to be modeled like a machine in its own right, then that gives you an insight on what amazing opportunities there are.
Yeah, thank you. Rosa, one of the things we have touched on is about robots and automation replacing the dull, the demanding, the dangerous kind of jobs. What do we need to do to reskill the people that are currently doing those jobs to then have gainful employment, hopefully working with the machines, as it were?
Yeah, so I think this is it's an area of reskilling and upskilling, and I think it's something, again, culturally that we need to be talking about in the UK. We're moving into an era of policy around something called the lifelong learning entitlement, and I think it puts us in a really good position to be able to think, well, what do we need to be doing to support people to adapt and to learn? And at the moment, I think it was mentioned earlier, there's a big focus on apprenticeships, which are a wonderful vehicle to support development, but not the only way. And so the skills system needs to be clearer. And I know looking at foresighting with the work the Catapult Group do, that access to that skills training needs to be clearer for employers and those working within them. And also, there's funding for those courses needs to reflect the skills that are needed. So we need to be able to upskill our academics, our lecturers and our trainers so that they are also confident in how to deliver those new technologies.
Yeah, no, that's a fair comment. Thank you. Paul, one very specific for you. Do you have an example where a company has supported the VEX competition and how that's helped raise the profile of industry and the skills in their region?
One specific example I can think of is MBDA. They're a defence contractor based in Stevenage. They've been working with VEX for over a decade now, and it's embedded into their CSR programme. They have their apprentices project managed for a year, the programme, and their graduates are linked to 18 different secondary schools around the offices in Stevenage. So the graduates go in on a weekly basis to support the team and mentor. And then the apprentices project manage the whole kind of process for managing the graduates, but also managing the competition, informal competitions they have, training sessions they have, and then a final end of season competition that they host at their offices. And originally the reason for getting involved was as a defence contractor. It was we're not all bad kind of story in kind of the local area. But actually what they've seen is, it's been a recruitment tool. There's students who were in some of them early VEX teams who are now employed by MBDA as engineers, but also the workforce development piece for their apprentices and graduates that helps to develop a lot of the core skills that they need, communication skills and working with students and communicating, which these people are coming out of universities with degrees, but maybe not necessarily all of the core skills that the business needs. So that's been a real win for them as well.
Great, thank you. David, this one's a bit tricky, so I'm not picking on you particularly, but how do we balance the negative image automation has with workers and unions, particularly in terms of the jobs point of view?
Well, as you know, I'm into my history, right? And, we had the Luddites who didn't like the mills, right? But at the moment, we've got probably the highest level of employment out. So we talk about skills crisis, but actually this technology, it migrates skills to different things. So it's not a zero-sum game. If you look at agriculture at the turn of last century, most people were employed by it. Now there's very few because we've got tractors and things like that. We haven't stopped eating, right? We still need food. So these things happen, but now so the employment changes. It's not a static, and we shouldn't be scared of it, because if we are scared of it, what's actually going to happen is it's going to go offshore. I think you may have said China 40% of robots.
Right? No, that was Graham.
Sorry, Graham. So but so the reality is, if we don't seize that initiative, it'll be taken away.
And I think that's an important point. The fact that we're running away from automation potentially because it's seen as a threat is actually incorrect. The threat is not doing it. Sorry, we've run out of time, so I'm going to close very quickly. I'd like you to join me in thanking the panel, and hopefully you found that. Thank you very much.
Mike, thank you very much, and thank you to the panel. I'm going to invite the panel to leave their chairs now, because we're going to go on to our last speaker before lunch. And I don't want to be rude to any of our other speakers by saying that we've kept the best for last, but we've certainly kept one of the most exciting and thought-provoking, I think you will agree. Richard Browning is also going to be around for quite a lot of the rest of the day, so I'm not sure we're going to have time for questions in this actual section. But as I said, he is going to be around to, if you want to pick his brain about anything that you have heard, you hear in the next half an hour. And I'm sure there will be a lot that will be very thought-provoking. He is the founder and chief test pilot of Gravity Industries, and he is going to be talking about reimagining human flight. Give a very warm welcome, ladies and gentlemen, to Richard Browning.
Challenge of all the stairs. Ooh, and I haven't fallen down them. Morning. So yes, I'm going to be sharing with you the unusual journey behind Gravity. As the years have gone on doing these talks, it has become more and more the case that people have some idea what I'm talking about from seeing the social media or general mainstream media about what we've been up to in the last few years. So it makes the task slightly easier rather than trying to explain right from the off that we build and fly jet suits. If I start at the beginning, though, and I should say as well at the beginning, there is a thread through this, which I think is quite relevant, not only from an innovation ethos point of view, but also hearing all this talk about STEM and skills. We might pause on that halfway through this as well, because I've made me think a little when I was hearing the last piece around maybe our relevance to that and some of what we've learned. So this journey started back in 2016. I was an oil trader in the city of London. However, my whole family came from the world of aviation and engineering, and I love a peculiar challenge. So I hatched this idea, which every time I share this sounds ever more ludicrous. I thought, could you take a human being, and what is the minimal technology you could add to that human being that would allow that human being to fly? So that is pretty weird. But if you take a human being and a bicycle and you didn't know what a bicycle was, you'd think actually, for a start, this device that when you let go of it, it just falls on the floor. You'd take quite some convincing that when those two objects are married together, they can bat round France in about 2 weeks with the right training. So I'm inspired by this idea that you can take
not only an inspiration from building and making things as a kid, and certainly an inspiration from how elegant flight is. We're a lot noisier than this. But from just how spectacular, really, human beings are. Now, this is not a necessity to fly a jet suit, but it was it's a very extreme demonstration of the principle I'm talking about, which is that isn't it amazing what you can do with a human being? I bet in this audience we've got people who have played every kind of sport you can imagine. We've got people who have maybe got some medical experience, so they understand how to fix human beings, right through to driving cars or flying planes. It's just amazing what we can adapt when we're talking about automation. We're starting from quite a high benchmark that human beings lay down. So if that's the machine you've got, what is the minimal you need to add to that? And the conclusion was it's horsepower. So back in 2016, this was the ground zero moment. There is a fuel tank in the mop bucket. It's not just fuel sloshing around in the mop bucket. And this was a big moment. And I think a pertinent point to the philosophy behind innovation that I feel very passionate about, and that is take a ludicrous idea and quickly, as fast as you can, identify what can you do to get your hands dirty to test that concept. And very much that involved dismissing about 4 or 5 general engineering assumptions, and as I say, my whole family came from this world, that this would never work, that the gyroscopic moment of 120,000 RPM spindle would be gyroscopically impossible to manipulate. Maybe that 25 kilos or 22 kilos of thrust in those days would somehow rip your arm off, but again, the physics is just like leaning. I had this assumption it would just be like leaning on a static surface, and that generally it would just be all too hot and you'd just be incinerated in seconds. All of these assumptions, having carefully designed the test, starting with bench testing, proved to not be the case. So inspired by what one does, you'll see a trend through this, got to the point of I was holding down a very sensible trading job, as I said, in the city whilst this was going on and didn't tell anybody. This is now 44 kilos of thrust, which is quite a lot when you point it horizontally. When you're leaning on it, it's very easy. Anyway, proved the principle. So emboldened by that, carried on getting hold of these little jet engines. This was one of my favorite stages, because still on paper, this is not enough to keep you going upwards, but you sure as hell felt quite light. And it was starting to validate the ludicrous theory that you actually, as a human, could manipulate and balance effectively those vectors. And when you think about skiing, surfing, snowboarding, and riding a bike, they are fundamentally less stable than actually a wigwam of thrust vectors. But the challenge was, where do you put the other engines? So your legs are pretty good at taking your weight, so that would seem to be a logical step. And also, I thought it'd be quite nice to have a safety tether not to hold you down, but to stop falling over on that farmyard, which I did quite a lot of. But it didn't work because it created essentially a 5th vector, which I couldn't see, so wasn't very helpful. The leg engines did show some promise, but we tried all sorts of different other avenues, and many of them entirely useless. But again, back to that innovation ethos, quickly identify how you can test the idea and then go test it as long as the downside is recoverable. I'll keep coming back to that. Obviously, the downside in this, as you could observe, could be quite irrecoverable if you didn't put some thought into it. So this was the model excuse me, that was starting to pay dividends. So this is called live learning your balance. What was weird was that when your legs felt thrust on the back of them, you could feel lighter and you could feel the support, but the soles of your feet that are flush with nerve endings were going, well, there's nothing there. So where's the ground gone? And you had this massive tendency to try and pedal, like apparently, and I again share this at every talk, and we've got a dog and I don't try it, but if you held a dog over a paddling pool, apparently they start to preempt the paddling. That was the same response that it felt like as a human that you want to actually employ. Anyway, we started making pretty good progress. So you've now got 2 engines on each arm, so that the net thrust vector is straight up your arm, and with roughly straight arms, it just felt like leaning on a surface. And the other 2 on the legs. Watch the knee bend. Oh, but I landed it and didn't fall over, so I was quite pleased about that. And then having started in March 2016, still not telling anybody, got to November 2016 and then did this, which is a grainy iPhone clip, and it's pretty unspectacular, but it sort of represented the moment of going from ludicrous, ridiculous idea to probably won't work to, oh, it does actually work. And at the moment I landed this, I had some little inkling that there was a potential of doing something pretty cool. I'm still fighting those legs. We've been talking more recently about rebuilding one of these because it was a ludicrous challenge. Anyway, to wind the clock forward, this is just a little spoiler of some of the stuff we've gone on and done. So as I stand here now, we've flown over 300 events and exercises in 45 countries. We raised $6 million last year on a $38 million post-money valuation. Before then, we hadn't really raised money. We accidentally in a parking lot in San Francisco with the Drapers, but it doesn't count. And that was only $500,000. But since then, we'd actually built a profitable company. We were book profitable, which is ridiculous from this. And that's because we applied the same curiosity and innovation ethos that we apply on the engineering side to the commercial side. So we have this enormously diverse business model that has generated fantastic revenues that have all gone back into the equipment and has allowed us to not just have something that could have been a 5-minute YouTube, giggle, into actually a very serious business. And I'm going to drop into some of those business model aspects in a second. Yeah, there's been quite a few events. Like I say, we will touch on some of these in a bit. But yeah, quite a step from that grainy farmyard back in 2016. So I'm going to keep talking over all of these. So one of the things I thought that would be quite fun is to prove, you can turn it up a bit if you want, is to prove that you could actually train other people. Because it's one thing, some ludicrous idiot proving one person can do it, but actually I wanted to prove that I've definitely got no special skill here. And so we've trained over 600 people around the world now, medics, military, loads of clients here and in Los Angeles, and it's been a really good revenue generator, but also an enormous enabler to things like those professional applications, the medic and military, to prove that when we actually go training those guys and girls, we are doing it from the experienced backdrop of dealing with the public, which is, it's a challenge in its own right. And just to prove a point, my kids learned when they were about 13. So all these people that think they're just going to rip your arms off, it's kind of rubbish. You'll see there's a grinning, skinny fool at the end of this, and that was my eldest son when he was only about 15, I think it was. So by having that tether, which I wish I'd had back in 2016, you can actually take out all of the bruised knee learning you do with your kids when they get on and off a bicycle and have to learn for the first time. There you go. And it allows you just to relax into it. And we've had people learn to hover this in about 90 seconds. Human balance, we have this module to balance. I've got better at doing this when I do talks. It's funny how hard that is if you don't think about it. But anyway, our human balance is remarkable. Being able to run across an uneven surface is a great demonstration of that. So training people has ended up being very useful. Yeah, relevant to what you guys were talking about. So we've had the privilege of literally dropping into quite a number of schools, even China back in the day before that got a bit tricky. And I tell you what, again, speaking as a father, there's one way of getting kids to properly put down that iPad or that iPhone, and that's land a nearly 2,000 horsepower jet suit in their school, shut it down and walk up to them, and then engage them in what the outcome of science, technology, engineering, and maths can actually deliver. I mean, we've done quite a few activations, even for the Great Campaign, the British government. We've represented the UK on stands all over the world. I have to say, alongside all the other things we do, it doesn't get as much attention as it deserves. And actually, the thought that occurred when I was listening earlier is if there's other corporates that want to step in and help us drive that agenda, it's close to our hearts. But yeah, we probably need support to drive it as hard as we could. I think we've got a great subject matter. And there's a very good reason why we've got a good subject matter, which is the next slide. But I think we would benefit from more help as a relatively small company still to drive that. So one of the reasons, I leave this in because the kids always ask it, and then actually it usually comes up as one of the adult questions. Have we ever thought about building an Iron Man suit? It's not what we intended to do. But while I let this play out, because we let I expect you're all familiar with Adam Savage. It's funny how some of the younger people nowadays aren't. Famous from Mythbusters of turning crazy ideas into reality. He's a good friend of mine. I met him at TED 2017, and he 3D printed in titanium all of that suit apart from the legs. And he used the CAD files from Marvel as well, which is crazy. We taught him to fly in 2 days, but then I got the stupid job of flying that with the eyepieces in. So I couldn't actually see. I could see a tiny chink out of one corner, which is why you see me doing this to sort of paint a three-dimensional render of where the hell I was going. It's a stupid thing, really, but it answers the question, so you don't need to answer that question. Of course, being America, they spent the next day shooting at the chest plate with high-velocity rifles, and it did actually prove to be bulletproof, but the wrinkle in the test was that the bullets fragmented, and inside the ballistic dummy, they found the shoulders absolutely peppered with all the copper jacketing that had slid off the breastplate into the shoulders. So I'm glad I didn't volunteer for that. Because I had thought if you could definitely contain it, the momentum exchange would look spectacular. But anyway, I'm glad I didn't do that. And yeah, you'd probably be right in saying that in the film, I don't remember a sort of colostomy bag feature stuck under the rib cage, but we had to put the electronics somewhere. So a serious point on this, In the UK, we look at, Marvel superhero DC and stuff, like I used to, as a bit of a silly giggle, and it's all very childish. Actually, America doesn't look at it like that. They look at science fiction as what happens when you take a human being and tell them to imagine and dream, not caring about money or physics. And every single thing that, I've got my phone somewhere in my pocket, all of this stuff around us has come from people not caring about what's impossible. They've just run headlong in, not always successfully, but run headlong into that ambition and given birth to the kind of companies you see all over the West Coast. So I think it's an important salient point for us, misery people in Europe and the UK. We need to try and engender a little bit more of that and take this kind of stuff, well, not exactly this, but some of this stuff a little more seriously. Out of all the audiences I talk to, this probably is the least useful, really, because you know more than I do about this kind of stuff. We 3D print everything. The suit that's sitting outside is all SLS printed in polypropylene, thanks to Ricoh. We work with Ricoh a lot. We've worked with lots of different 3D printing companies over the years. The process is brilliant, as you know, because you can keep changing your mind and you haven't got a $100,000 injection molded, commitment that is staring you in the face that you have to go and change. So we used to do a lot in aluminium. We've even done it in titanium. Sounds cool, but if you have a crash, all the shock goes to you and the item is fine and you're not. Whereas polypropylene is pleasingly bendy and almost human-like in terms of being a much softer material. But we've had great fun with that. In fact, that arm mount was the one we gold-plated as our prize in Dubai, which I'll get to in a bit. I've thrown this in because I do observe a lot of companies, they maybe have a breakthrough. I think poor old GoPro is a good example. Amazing breakthrough to turn a TV camera into a tiny box anybody can stick on their heads. And then they just coasted, I think, had a few crap products, and then missed the boat with 360 cameras, for instance. I don't want to be that kind of company, so we did this kind of stuff, which if you think about the Harrier and the F-35 using vectored thrust to fly, this is the logical next step. Well, maybe logic, I don't know. The next step. So by vectoring that thrust backwards and generating aerodynamic lift, by generating forward speed and therefore airspeed, you can generate aerodynamic lift. And it did work. The only reason we stopped doing this is because the speeds got so high. But there you go, transitioning. Not like the modern kind of transitioning, the transitioning of flight type. That was a fantastic learning experience in real life. I remember distinctly to the day I die, and it wasn't the same overlap, that actually flying up into the airflow, feeling that acceleration, and then that distinct feeling of like, okay, how do I get out of this? And for what felt like about 3 or 4 seconds, watching my end target looming and the water running out in this lake we used to test, thinking, how do I get out of this? And it was very simple. You just vector forwards, which slows you down. You then just lose all the airflow. And I turned the power down as I'd gone up into the cruise. And so I just plummeted and luckily dialed the power up just to skim the water. I should throw that clip in. But anyway, learning in real time, I do joke that I'm the founder and chief test pilot, but genuinely it's me that puts myself up for these tests. And this being the culmination of the wing work we did, I think this was 2018 now, which seems a long time ago. We stopped here because you'll see the speed we got up to. And the only reason we got 2 pilots out there was just for the cameras, really, although this guy got quite close to the waves. And they were supposed to see me off as I went to see just how fast you could go in short order. So here we go, starting to transition, getting aerodynamic lift in that ram air leg wing. The strakes proved massively useful to keep your head at the front and your feet at the back. That is kilometers an hour, to be clear, but that was way fast enough. You don't want to go any faster than that. And then you have to brake, turn around and come back again. So as I say, we have not lost that spirit of wanting to explore. It's all about what happens when it goes wrong. And hitting the water at those speeds, very low down, was going to be akin to the jet ski accidents they have every now and then. You tend to get knocked out, you tend to possibly break a rib or two, but the way we were going to float me, we were floating me, would be face up. So right at the edge of the acceptable risk in the pursuit of science, but we stopped there. This slide, I'm very proud of this. I've slightly lost my voice because I picked up some horrible bug with 25 of my team in Dubai. Not last week. Yes, was it last week? I don't know. I think it was last week. And we put this on. You can turn up the sound a bit on this one. This is the 1-minute summary of the race series we launched in Dubai. The city dropped about 2 million on this, and this was just a showcase. I've always had the ambition that if it looks pretty cool to do a single pilot demo, imagine having a whole bunch of guys and girls all racing these, not only our professional clients, but also our public clients, all celebrating human-machine achievement, if you like, in a safe environment over water. Think Red Bull Air Race, but lower and slower, but with humans, as in humans flying jet suits. And that's what we delivered. And so this is very fresh.
Well, here we are for the world's first ever jet suit race. 8 pilots.
I'm going to enjoy this because it was a busy couple of weeks.
First ever jet suit race winner and have their name etched in the history books. And what a place to do it in front of this incredible Dubai skyline. And we are off. An aggressive launch, I think, there. They head off down to that first pylon. It is neck and neck, and around they go, continuing down very, very low to the water. But he's trying to get himself back up in the air. Oh, he's in the water.
It does float, as you've just had demonstrated.
Yes, he's now taken the lead.
It was an idea that many people said was impossible. It is such a special feeling to be moving in that three-dimensional, almost dreamlike state, but with other people feet from you, experiencing the same thing. It's truly like a dream. Just think or look where you want to go, and that's where you go.
We came here with the question mark, would jet suit racing be exciting? I think it's almost too exciting. I was quite tired at that point. My nerves were fraught with trying to deliver all that. Anyway, that's the beginning of the series. It's going to tour around the world is the plan. It's just another whole aspect of what we do. Yeah, I quite enjoyed watching that. Now, the professional division, on the other hand, so that's all entertainment and colourful and fun and looks a bit like Iron Man. The other side of the business is medic response and military work, and I'm trying to leave enough time so maybe we can do Q&A, but you tell me. This side has been really fun because this is the grown-ups in the room. You know, doing racing, no one needs to do racing, but no one needs to do Formula One racing, I suppose. But this side of life is really interesting. I was in the Royal Marines Reserve for about 6-7 years, which helped a lot. So that maritime community took us pretty seriously, surprisingly seriously right at the beginning, and now the gear has got so good that we are actively training, really, right now, a whole bunch of Allied Special Forces. Sadly, the UK gave us an enormous shove at the beginning and then sort of ran out of money and people. But anyway, we'll, I'm sure, circle back. This is now changing the game in Special Forces mobility, and I'll talk over this, as usual. But on the medic side, it's exactly the same ConOps, concept of operations, but you're just wearing red and turning up and being friendly. So as I play this, let's talk about medic side. So if you think a medic on a paramedic, on a bicycle or a motorbike, they cut through the traffic to get to a casualty really quick to address that life-critical breathing or blood flow or pain management. We can go up mountains, as you might have seen online. We scaled Helvellyn in 3.5 minutes. There's a very brief clip of it buried in here. When it took 1 hour and 20 minutes to walk, and the weather was so bad that all the drones and all of the helicopters couldn't operate. 3.5 minutes. Through the fog, just navigate with the phone, look down, see there's the ground, I can stop if I want. So on the medic side, we're making great progress. We're in a variety of countries exploring it. On the military side, a lot of people that maybe don't have a military perspective think you should have twin miniguns and hovering around the battlefield, just strafing targets. The way you've got to think of this is underlying ethos of special forces, actually even infantry, is fire and maneuver. No one runs across the field trying to take pot shots at anything. You only maneuver when you are covered. And our system allows you to do that maneuver leg now faster than Usain Bolt over mines, mud, wire, water. We don't care about drone countermeasures. We don't care about anti-aircraft systems in most cases. And we can deliver onto the objective night or day, any square foot of the terrain, do what you need to do, and then importantly, self-extract. And so we were in Ukraine for 2 weeks with General Zaluzhny. We didn't publicise this. We got personally invited out there and we demonstrated that capability. They are fully signed up, admin-wise, challenging. But it was pretty humbling to get out there and have that amount of time from that man to get his feedback that this was a game changer. And again, same thing. This could be a minefield. There's no minefields in the Lake District. But as you see the stats that popped up there, this is a very short edit of it. The camera doesn't really do it justice, and you'll see there you go, that does. You see the stats there. So 1.2 miles horizontally. I think we gained about 2,500, 3,000 feet and literally land right by the trig point. So as that kind of plays out, I just want to reflect and see if we've got those 7 minutes of Q&A. I just want to reflect on when I mentioned about innovation ethos. When I was a trader, it was all about waking up every day, trying to come up with some funky new ideas that you didn't have yesterday, realizing that most of them would fail, but then the failures had to not put you in prison, not run you out of money or patience with the management, and leave you fighting another day. And on average, if you kept plotting your progress, if it carried on going up, that was success. I think innovation is exactly the same thing. I think if you run away from risk, I'm sure lots of you agree with this, if you run away from risk which so many big corporates and government departments just do all the time, endemically, you run away from any innovation. And ironically, the people pushing that agenda are creating the biggest existential risk possible for that government department or that country or that company, which is that if you don't innovate and keep up with your competitors, you are literally going to hit that iceberg catastrophic event at some point later down the road. So how ironic that the risk mongers out there that are constantly trying to get you to hold the handrail going down the stairs, in BP it used to be the case, are not letting a culture actually reinvent the next product, the next service, and keep competitive down the road. But there's a solution, which is that you don't run away from risk. You simply, sensibly analyze what is, and it sounds a crass statement, but it works really well, what is the worst that can happen if you take that risk? And in most cases, it's manageable. In the most cases with those engines in that farmyard, it was falling a couple of feet onto some concrete with some knee pads on. There was no way those engines could all overspool, and even if they did, you just vector them out. So actually, when you really understood the actual downside risk of what you were doing there, and by the way, jet fuel behaves the same chemically as diesel, so it's actually less dangerous than the gasoline in your lawnmower. There's lots of these, when you get into the detail, actually you could manage the risk. Look where you get to with it. And I feel like in big corporates and governments, if we only had more of a measured risk-taking appetite, we'd be a little bit more like West Coast of America, not that they're perfect by any means, but we'd have a little bit more of that innovation ethos. It's that catastrophic fear of risk that is the killer. So on that, should we just, I've probably broken the system because you were supposed to type questions, I think, weren't you? But
No,
anyway,
we are sorted. And I do have some questions, but you do have a couple of minutes to send some more questions in on the iPad. But before we turn to questions, let's just give him a round of applause. So much to cover. It was fantastic. So one question that somebody's asked, which I have to say, I also was wondering, how come you didn't win that Dubai race?
Yeah, I know. Well, when the full edit comes out, it should be, I think, end of next week, and it should be really spectacular. That was 1 minute. There was so much drama, even in the heats and everything. You'll see in the final 5-pilot race after all the heats, I absolutely hammered off like a rocket and got way ahead of everybody, and then went really wide in one of the corners. I sort of did, I don't know. I'm the old man in the team. I'm 45. Everybody else is half my age. I want my guys and girls that were racing in that team to actually properly give me a run for their money. And they actually clocked higher. So 2 of them clocked higher top speeds than me as well. So I don't know. I want to let them take some wins, and then I'm going to try and catch them back up again.
I'm going to throw quite a few at you so we can do a lot. So how long does a full tank last?
Not very long. So you can't make something small, light, and very efficient, and very powerful. So the one that's sitting outside will do about 4 minutes, but I can put it on in 20 seconds whilst it's starting up and be in the air in a total within about 34 seconds. And then let's make the maths easy, 60 kilometers an hour, night or day, any weather, anywhere you like. So 2 minutes later, I'm 2K away, shut down, shaking your hand if you want. So it's a short, last mile kind of system.
And somebody said, why not use a hoverboard style?
Oh, Mr. Zapata, probably you're thinking of. So there's a big elephant in the room with that. A, he's the only human being that has ever learned his 600 hours to fly it, bearing in mind it takes our people about, right now, the people training right now, about 20 minutes. And also, where do you land the hoverboard? If you'd ever notice Mr. Zapata with a hoverboard, he has to land and take off from an 8-foot grated platform. So it's great to launch, turn up, hover around and go back to where you came from again, but that's pretty limiting. And again, unless you watch too many films, you don't need your hands in the air. We've actually got helmet-steered weapon systems if you have to do close order protection, provide cover. But that's not the point of it. You're not running around, flying around with no cover from sight or fire in a battlefield. Anyway, it's another big subject.
What's the biggest challenge you're facing in your business at the moment?
Too much demand. You know, business is about supply and demand. You keep pushing and leaning and trying things, and we've tried all sorts of things, and actually more than we thought has worked. So now we're going to do another raise because we've still got loads of money in the bank, but we are now not a $38 million company. We're easily an $80, $100 million company with what we've got coming.
Nice problem to have. Now, this comes back to the culture question that we've heard so much today about, why aren't we adopting robotics? Why aren't we automating? Why do we have the skills gap? Why don't kids want to get into this area? How can we enthuse? Because you've had a very enthusiastic reception, particularly with kids and so on, but you can only reach the kids you meet or the kids who see your videos. How can we scale that up? That enthusiasm.
So my 2 boys, as I mentioned, who fly, and they're very hands-on. One's got blacksmithing gear and the other one takes cars apart and all this sort of stuff. I was letting them use angle grinders carefully when they were like 12. And, you know, it's nerve-wracking as a parent, but you carefully coach them and allow them to do this. They both don't do DT at school because they get to sort of sand a piece of MDF carefully as long as it's not too high grade in case you graze yourself. You know, what are we doing? I mean, we should just ship all our kids out, I'm going to be careful how I say this, to spend a week in Kyiv, in Ukraine, just Kyiv, nowhere else, nowhere further east, and just breathe in the ethos of, you know, a risk-based approach of getting shit done. Because that country, for necessity, is a brilliant example of that kind of behavior. We've got so soft and floppy and, you know, risk averse in this country that we're just going to pay the price for it.
But on that, I take your point about Kyiv, but that's, you know,
an extreme example.
An extreme example, exactly. But are there, obviously you're traveling a lot, are there countries, you know, we've mentioned Germany already, which I think everyone in this room knows is not the, you know, the nation necessarily that we want to be copying at the moment. But are there countries that you've been to that have learnt how to harness innovation and technology?
Yeah. You're not going to like the answers, but yeah. I mean, one of the ones that's just deeply impressed over the years, not politically correct to say it, but it's China.
Yeah.
At 2 o'clock in the morning their time on a Saturday, we were being hassled by the 23-year-old female salesperson for the race obstacles that we were getting, you know, trying to offer us more ideas. I mean, and yet how many of us in this room are chasing UK suppliers 2 weeks later because they just can't get around to it?
Exactly, and if it's not China, people will often say, you know,
it's up and coming.
UAE, people will say Saudi, and of course there is something that they all have in common in that their politicians don't need to worry, or their leaders don't need to worry about votes, and therefore can take long-term initiatives.
It's difficult, isn't it? There's an element of that, but it's also when you're in a culture like China that within living memory was having mass famines. You know, Granny and Grandpa survived mass famines and are still living in a little village with a pig on a string. You are going to work bloody hard in your little flat. Yes, it's that hunger. I often used to say to my kids, it's stick and carrot. I want you to be inspired by where you can go, but actually in no doubt that the world is an ugly, miserable place, that if you don't work really hard, you know, be scared, be fearful. And I don't think that part of the message ever gets through. It's always, don't worry, safety net, you don't really have to try.
All right,
it drives me mad.
We've got an extra question from the original hoverboard questioner who says,
hoverboard.
I meant on your feet, shoes or legs, air or blow powered.
So as you saw, when you attach thrust to your legs are really very autonomous. When you really think about it, your hands are close to your brain. I know this isn't good biology, but you feel very in control with them. Your legs, I can do this and I'm not really thinking, I'm just commanding myself to walk this way. And when you run, you have a real autonomy of running. So it turns out when you mess with them, it's quite a hard learning journey. There's that. And also the freedom to be able to operate with something on your legs is quite difficult. We can fly in deserts, we can fly all over the place because you can vector the thrust. As soon as it's on your legs, wherever you land, you'll dig a hole unless it's hard surfaces. So it's quite, and you can't get in and out of it quickly. So we will rebuild it for fun at some point, see if my team can fly it.
Well, thank you for your questions. As I mentioned, Richard is hanging out. You can see the pack. You can go and talk to him, for those of us who are lucky to be here in the real world rather than virtually. So go and chat to Richard, have a look at the pack, find out more. I also, just before we break for lunch, need to tell you that there is a How Made Smarter is helping SME manufacturers adopt digital technology session over lunch now, which is in room 7 upstairs. We are now going to break for lunch, but if you do want to go to that session, there will be food there, so don't worry about that. We will reconvene at 1:30 here in this room, but now please give Richard another big rousing round of applause. Thank you very much. Oh, and I think that's yours.